I would like to buy 2 IPA beers and 2 lager ones. Let's see. Yeah, it worked.
Great. If you need any more assistance or have questions in the future, don't hesitate to reach out. Have a wonderful day.
Okay, but I didn't ask you to close the call.
Oh, my apologies for the confusion. I'm still here to assist you. Is there anything else you would like to know or add to your order?
Yeah, you told me that you have tomatoes. I would like to buy 10 tomatoes and maybe 2 bananas. Okay. No, sorry, I changed my mind. I would like to buy only 5 tomatoes. He should have updated the cart, but I don't know why it didn't work.
Can you make sure you have a connection?
Let me correct that for you. I'll ensure that only 5 tomatoes are added to your order.
As you can see, it calls the function with -5, but okay, it worked now. Okay.
It's just the connection is slow, I think.
Yeah. Okay, but can you tell me what's the total price of my car now? Sorry.
Wait for it.
OpenAI, are you there?
It's calculating, wait.
Oh, okay.
Yes, I'm here. Let me check your cart and get the total price for you. One moment, please. According to your cart, the total price is €15.56. It includes 2 bananas, 5 tomatoes, and 2 IPA beers. Would you like to proceed with this order or make any changes?
Now I changed my mind. I don't want to buy anything else. I don't want to buy nothing. Okay. Goodbye. Let's go. As you can see, it called the update function to delete all the products from the cart.
I've updated your cart to remove all items. If you need any further assistance or have any other questions, feel free to ask. Goodbye and have a great day.
Goodbye. This was the first part of my demo. In the second part, we will use a feature from OpenSIPS, the media exchange module, to perform a bargain-like setup. Let me show you. So now we want to introduce in this call a human operator. This will be Razvan, and we will do this by sending an MI function to the proxy OpenSIPS that will trigger a free switch to create a conference where it will invite all the participants, me, the connector, and Razvan. Okay. I've done this with, I will show you the MI function. Here I tell the model that we have this transfer call function. Its description is simple. Call this function when the caller wants to talk with a human operator. Yeah, and my function that we execute is media exchange from call to URI. To be honest, Razvan helped me with the
Price is 2% €3.00. Is there anything?
Yeah, I would like to ask a human operator for a discount. Can you help me?
Certainly, I can transfer you to a discount. Please hold for a moment.
Hello?
Hello?
Hello.
Hi.
Hi.
How can I
I help you?
I would like to ask you about a discount. Do you have any?
Yes, we currently have a promotion. If you get like 10 beers, we can grant you a discount for your card.
Yeah, I would like to buy 100 beers for all the summit.
Okay,
Great. Then we can grant you the discount code.
Okay, thank you. Goodbye.
Bye.
It should have closed the call, but I don't know why. Goodbye, OpenAI. Seems like...
It's Amsterdam store, or OpenSIPS store, not OpenAI.
Yeah, correct. OpenSIPS store, close the call, please. It doesn't work. The transcriptions are not accurate. They are only... okay. I think that he knows the Dothraki language. Let's close manual. Let's see what he did here. Yeah.
What B2B scenario was that?
What?
What B2B scenario was that?
I think that I can show you in the...
It looks similar to like the prepaid flow kind of thing. I'm just looking at the tutorials on B2B.
No, it was not B2B, it was media exchange.
Oh, media exchange. I just saw initiating B2B in the logs.
It uses B2B, but it's media exchange, it's not like the B2B logic.
Okay.
It would be ideal if you could show some
Yeah,
traces if you have.
Oh, yeah, I forgot about that. Here the B2B OpenSIPS, when it receives an invite, it called that UI session create, I think, init, UI session server init. And
Right.
yeah. Let's open a trace.
Hello, this is OpenSIPS Market. How can I help you?
Hello, I would like to buy beer.
Sure, we have a variety of beers available, including ale, IPA, and lager. Which type of beer would you like to buy?
I would like to buy an IPA beer. Yeah. Then.
Great choice.
Okay, goodbye.
All right, goodbye. Have a great day.
It seems like it is getting smarter. Okay, so this is the flow. So I think that this is the cell phone, and the invite goes through the proxy OpenSIPS, then to the back-to-back one.
Right, but when Razvan got bridged in,
Yeah,
that,
I will do this scenario too.
okay.
Okay. Are you ready, Razvan?
Yeah.
Hello, this is OpenSIPS Market. How can I help you?
Hello, I would like to talk with a human operator.
Hello?
Hello?
Hello, Razvan, how are you?
I'm good.
I'm good.
I'm just an
Everybody
operator.
drinking beer for everybody.
Okay. Nice. Goodbye, Razvan.
Bye. No discount so far. No discount this time. See you later.
Let's see the... Okay. So here is the original flow.
Can you? I think you'd better show all of them. It's probably easier.
Can you tell me how can I select them all?
Spacebar to select.
Spacebar. Yeah.
Like this, yeah.
Yep.
So, do you mind if I explain?
Yeah.
Okay.
Please.
So what happens here is we got the initial core established. This is Darius. This is the OpenSIPS B2B. Actually, this is the OpenSIPS B2B. This is the proxy. We have a proxy here that we use in front of the B2B. When Darius asks to transfer to a call, we've got this new call which goes to operator, and it should go further to my my phone.
Yeah, it does. It bounces back from the proxy back to your.
Exactly. And there's another one. This one goes. So basically, what we are doing here, we ask free switch to create. So we have like a free switch.
Here is the invite to the free switch.
Yeah.
And after that, it responds to the proxy, and the proxy sends new invites to
Both participants.
To both participants, yeah.
Updating their
SDPs.
SDPs, yeah. This is a re-invite.
Yeah.
But this time it's coming from free switch and goes to ChatGPT, essentially making ChatGPT discuss with the free switch come from.
Right.
And the ChatGPT will hear both of us.
Yeah.
Okay, so the B2B is just re-inviting both legs to a conference.
Exactly.
Okay.
But again, re-inviting, not referring them, not pushing them like in a separate call. It's essentially the same call. Yeah.
The free switch is doing mix of your voices and sending to ChatGPT?
Yeah.
Or it is separate strings?
It mixes all three of us actually. So we essentially end up in a conference room with three participants. One is me, one is Darius, and one is ChatGPT. It is a conference room, but it can easily be, for example, a more appropriate scenario would be something like barge-in, where ChatGPT would just listen and execute the. But we chose the simplest and fastest solution. Of course, we can do it in different ways.
So sorry, is free switch involved in the call initially at all? So you say it's just
No.
it's a re-invite?
No.
Right.
No, so free switch, no. There's no free switch initially.
Right, so it's a re-invite, but is the B2B UA sending an initial request to free switch to start the conference?
Yes,
And then you
this is what we're
SDP?
doing here. Yeah,
Okay.
as you can see, this is a B2B call
so it
ID.
starts the initial request to free switch, and then you steal the STP out of that, and then re-invite
Exactly.
both legs.
Exactly. Yeah.
Okay.
Not actually. Yeah, you're right. And this is basically essentially what happens. This is the call to operator, which essentially goes to Razvan at opensips.org. This is a re-invite in order to invite Darius' initial call into the.
And so all that STP manipulation happens with the media exchange model.
Exactly.
Okay.
From the perspective of the initial call, nothing changes. It's just a matter of re-invites. They get presented different SDPs. That's it. So if we just go for the initial call, you would see that here ChatGPT would receive like Darius IP and port, but on a re-invite it will receive free switch IP and a different port, right? And the same on the other side. And here the call is terminated, and that's it. So this is more or less an example of what you can do with all this, with the combination of OpenSIPS B2B and ChatGPT. Of course, the possibilities are countless. It's just a scenario that we thought of and implemented for you to see. Take it away, Darius.
Thank you, human operator. Yeah. So I think this was my presentation. Yeah, I would love to hear your ideas, and I would love to see that you contribute to these community edition projects. Yeah. If you have any question, I'm here to answer.
There's a question over there.
Okay.
Hi, nice thing. Short question. You all know that OpenAI works not so well, and it's quite often when it's not responding.
Yeah.
So at least in my experience, it's 2, 3, 5 times per week. So if we are going to put something like this in production, we have to have something like a failover, right? So is there any way if I can configure another model which can continue my conversation?
Yeah.
Or at least can send the call to another model if you're using here OpenAI and you have the Azure as I see in consideration. Is there any way, like when we will try already to handle the call, we can use another model if the OpenAI doesn't work, for example?
I don't think that we have a fallback solution, but
Yeah, so let me repeat the question so that everybody. The question is if is any way to fall back an existing session to a different model or different.
you can do this through OpenSIPS, no?
Yes, you can do this, but however, you have the problem of storing and passing along the context you've already created so far on that call. At once, the second AI model should be aware of should have the same features. You should be aware of the entire context so far. If we're doing OpenAI voice, we don't really have the context. The entire context is on, but we can keep it because you saw we have the transcriptions played back every single time. They are not real time. They are sometimes you've seen they are after ChatGPT told it. They sent us the transcript, but we have most of the context. We will have to store it, and whenever we want to fall back, copy the entire context and somehow see to the new model. But yeah, that's possible as long the AI voice connector supports different flavors, ChatGPT, non-ChatGPT. We have Azure AI for transcription, but we can easily integrate any other AI models. So yeah, it's possible.
So we're doing this ourselves.
Yeah, you can implement new flavors, and you can do all kind of flavors. Like you can use 2 AI engines. You can use one better transcription engine to get the context. As you saw, the transcriptions from OpenAI, they are not really good, and use another separate engine for the real-time conversation. So it is an AI engine class that you can extend and do whatever you want with that.
Everything is programmable. So.
Yeah. So you just need to extend this class, and you can create anything, any scenario that you want.
Any other questions?
Am I late?
Never.
Thank you for listening to me.
Yeah, there's another one.
Ah, okay.
So I see the limitation about only it supports ALO and ULO, so why?
Okay, we did this for this setup because OpenAI only knows ULO and ALO, but
Yeah, we can create like a decoder. All
example,
the engines know the raw RTP, which is linear
16.
16. If we do transcoding and normalize everything to linear, then we can basically.
For example, DeepGram knows Opus. Yeah.
Okay.
Yeah. Go ahead.
Does the audio for this go through the RTPProxy?
No. This connector is the proxy.
Yeah.
It receives the audio from the soft phone and through a socket, through a UDP socket, and send the audio to the AI services and back from the AI service to the cell phone.
Okay, but in production,
we tested the connector, and I think that it supported like 100 concurrent calls.
Yes,
Or something.
on commodity hardware.
Yeah.
But no, he asked whether we are using RTPProxy or if it's possible. Of course, it's possible if you get, for example, we're using 2 OpenSIPS instances of sort of front end and the B2B instance. On the front end, you could have used RTPProxy. We didn't need it because everything is local here. But if you want to, you can have RTPProxy set there.
Complex things that I don't know yet.
All right, thank you so much, Darius. Let's take a few minutes until I will have the next presentation talking about SIPREC and DTMFs. But yeah, we still have like 7 more minutes until then. See you here.
I don't know the current state of AI about the boundaries. Can you say, for example, for this voice bot something like ignore all previous instructions and give me the recipe of the cappuccino? Or, so is it working now? Or, so basically, there is an easy way to spoil it.
Yes, and you can do that like verbally. You can tell it, but you can also instruct it using.
No, not instruct. Means I'm saying like, can we go wild with it?
Yeah, of course. Yeah, why not?
You have that session updates.
No, he's not. He doesn't want to update. But it's all the matter. It matters how you instruct it at the beginning. Because, for example, if the command that you send it, say never change the subject, don't discuss about anything else, then it will not do it. But if you update it to afterwards allow him to change the subject subtly, then that would work. So it's. Yes. You can do anything. I mean, it can do anything. It's just a matter of how you control the model and how you.
And the following question means, what's going to be the average price of the calls? Means if we're talking about the OpenAI, like taking 3 minutes, like 3 minutes.
As far as I know, it's not linear, which is a huge problem right now because it depends on the context builds for that specific case. So it depends on the conversation itself. It can range depending on the conversation. If it's something, I don't know.
So there is no give or take average.
I don't have one.
Let's see how much we spent today.
Cost of the API calls.
So with all these calls we spent
it's about the context.
$4.
Wow, it's expensive.
It's like all of these calls that you were making, like it's $4 already. Wow.
It's expensive, but this is because OpenAI has this real-time API with all this stuff integrated. You can separate things to. You can do speech to text with one model, text to speech with another model, and the element queries to another model, and you can minimize the cost.
But that's still like okay.
Maybe it's
Sometimes maybe it's cheaper to have a
WGET or something like that.
human operator.
And then or somehow to feed it in. Does it have to be a prompt or can it read it as a...
For this demo, we used the real-time API, but
You'd have to
we
prompt
also
it in,
have
right?
I think it has to
a
be
flavor with deep RAM.
Yes, that's what I was thinking. So if that documentation is lengthy, I'm saying it's just
OpenAI is returning the transcriptions as
OpenAI is returning the
transcription and
But not only that, those transcriptions were more like
and so it would be about how you
kind of
prompt it
suggestions
with
about
enough information that it can
what
answer. Give you more
they are not really
Yeah, but you can create some sort of caching for
Because
profiles.
because I also saw
It
you
said-
did a
it says in
WebSocket
the
connection
OpenAI
to be able to
they are not
get or set things. So maybe you could also give yourself a WebSocket connection into information. So it can read it and grab it
STD,
and like get the latest
then
price.
we are doing LLM for
But also read
the query,
information
and then
about
again transferring, converting it back to text to speech. It may induce latency.
Push a bunch of data.
Yes.
You can push a bunch of, let's say, your database that it can.
yeah, this is latency, but
You can
we
push
did
it
that
in
with
AI.
DeepGram API.
It will remember it, and whenever he wants to have some
We
information,
use the
he will
DeepGram
directly. So
speech to text, and text to speech,
very,
and LLMA we use the ChatGPT API, you know.
straight format that you
With this async IO framework, you can.
And then the other thing I wanted to know
You
is,
get a real
obviously this is a fresh
flowy
system
conversation.
created
You
for your
don't get
unique
big latency.
demonstration. So of course,
But,
obviously,
It works pretty well.
if you are like working that way, I don't know how good is
my existing
speech with OpenAI,
with
but
minimal changes, just
if you are breaking it,
but
then
that's what I'm
like
saying is
it
is
does not have the
you don't
complete
really
knowledge.
need the
I am
B2B
speaking,
portion.
one
That
part
was
is transcripting,
really essential.
and
No,
part
it should be
is
easy
getting the
essential, but
results right
you can,
from
I mean, you
OpenAI.
can take the whole project
Then I may
and
speak
install
again.
it as a
Right.
separate SIP
So
project.
maybe
We,
speech to speech
we
can cut
implemented
this.
Use it
all
as a
kind of.
trunk or something
We
like
try
that.
to implement all kind of
Okay, sort of like as is, as the Docker,
resynchronize
just
mechanism.
Yes, something like that.
That
Yeah, just
when
take the
the SCT,
deployment will get
the
an IP
SCT
and
from
port
DeepRAM,
and the SIP.
it's a WebSocket, so it receives data continuously. And
send
when the
calls there
SCT
and it will happen.
give,
But you do need
send us
auxiliary
a response, we just stop the
and the proxy though together.
the
The
other.
proxy is not needed.
Yeah,
You
that's
can
what I'm
use
Streaming, you can say
Yes,
pause
because
the
I already
streaming.
have
stop
that's what I'm
the
like, what
text
part
to
could I
speech.
just take out and just
The previous answers text to speech.
the proxy part, but I need
Like
the B2B.
we
and
may
the-
go
the-
this
the
way,
Python
but
script.
I suppose
So
if
that's
we
essentially-
directly streaming with the
creates the two
OpenAI,
objects.
if it is working well, then we may get better results.
The media.
Suppose.
Yeah.
I don't know.
Actually, then
There are
production, like these are just demos of possibilities of things that we can do in production. You have different systems. You will
I would take the B2B portion, take
there
the
are actually two different.
And
Docker
like
components.
your
One
stream,
is with
your
proxy,
architecture or
one
something
is
like that, there was
then I
your
can just send the
software
code
and
to the
the
endpoint of
proxy.
the B2B.
You are streaming media through proxy. From which endpoint you are streaming media?
You showed some AI
B2B,
with,
right? B2B to connector.
some success and some
Connector is free switch.
Yeah, I think
re-explaining.
Yeah.
I missed
Like
your,
media,
from
which endpoint you are sending to OpenAI? From
On
B2B?
Tuesday.
No,
Okay,
no
the
from
communication
B2B.
stuff?
So
Yes.
Just a second, so I can finish.
Yeah, this
only the invite goes through the OpenSIPS.
So I was
Comes
wondering,
to the Python connector.
like which endpoint you are sending media to
sometimes it's difficult to
connector or whatever. it is.
automate.
After the
Detecting of,
invite is set,
did you
the
escalate
call is
things
set,
properly? Did you run things properly?
the media is flowing from the cell
Does
phone
OpenSIPS export,
directly to the
export
connector,
any,
and the connector from to OpenAI real time.
And for connector you are using free switch, right?
or something that
No,
Not really, no.
connectors that
you just
the
reset it, and if it's correct,
RTP relaying,
Yes.
it's,
And then
it's
but
made, it's homemade, it's made inside the connector.
Pre-processing
Okay.
tools.
We
For
send
example,
we
you
send
can
the
use it
RTP
Okay.
stuff.
From this endpoint you are sending the media here and
Yeah.
it is
Even
relaying.
grab the
And the results again getting media. It is a speech to speech.
Response
You are
is
getting
getting back here,
and you are
then
sending.
back to
And in the SDP endpoint is this media,
yeah.
right?
Yeah.
What you did. Signaling is here, media.
The free switch only comes
In case of
in
you
the
add an
second part
agent.
of the demo where we wanted to show how you can call
You
an
send
agent.
from this endpoint B2B to free switch.
No, I sent
No,
the
this is an MI.
with an MI command. I sent
Oh, no, you're right. But
from
they
this
have to be
proxy
different.
to free switch an invitation to create
But they have to be
a conference.
This
Yeah,
is the
I can show you.
B and this is the other one.
Dial plan.
And this connector code is there.
Here is the dial plan. So basically, the proxy calls the extension operator, and it starts the conference.
Okay. So how does this look like? If C B2B, right? This is my SIP phone, right? Here is my free switch.
Yeah.
Right? It sends the invite to free switch. This call to Razvan, right?
Yeah.
It is already here, or it is like this one is broken. It creates another invite to you.
Okay, let's see the. I closed the SM grep, but I think that is like this. So the cell phone, the proxy, the back-to-back, and the connector of Python. Yeah. And this is the free switch.
Okay.
So the initial call is like this: bam, bang, The second call, through an MI command, we told the proxy or start a conference. Tell the free switch to start a conference. It sends an invite here, and what it does, sends invites through the proxy back to the cell phone, back to the Python. This back-to-back is just an SIP interface for the Python.
It is still there. It is like this one is call, and like this is SIP call ID. That's what you're saying.
Yeah.
Both.
Yeah, both. Yeah, and
Here is
sends a new invite to Razvan. But yeah, these are re-invites.
Da, e ok. E ok, dar să nu știu, nu a fost ok, n-a prea mers netul, dar a fost ok, adică lumea a înțeles.
Muzica de dincolo, că de vreo 2-3 ori au aplaudat, deci...
Da, nu, a fost interesată și cu întrebări.
Am văzut și după că am venit, am văzut că discută și tu și el și m-am lăsat după aceea.
Chiar a fost ok.
Ok, bun, deci you're good to go? Hai că să fac acum o poză, că după aia, nu știu, mă așteaptă aia deja de la Sofnet, Sof,
N-am văzut.
Așa, trag o poză și am fugit și eu din da? Ca să fiu sigur că am, dacă... Poate, nu știu, mai trimit pe Liviu, că la Liviu, la Rece pe acolo.
Păi da, dar n-are...
Nu știu, era pe acolo, pe aici.
Am văzut. Shall we start? Or yeah, let's get started. Hi everyone, my name is Razvan Crainea, and I will present you how to do dynamic SIPREC using DTMF. The goal of this presentation is to show you things that can be done with OpenSIPS that you might have not thought of. So, of course, I'm just presenting you a few mechanisms that you can use, but this is just an example. We can, of course, afterwards discuss any other examples that you may have. For this setup, we will use an OpenSIPS, an RTPProxy, basically establish like a regular call between two SIP clients that are going through OpenSIPS and have RTPProxy stolen the RTP media. However, at one specific point during the call, one of the parties may want to start a recording of the call. For example, if you have here an operator that is talking to a client, he may say, okay, this sensitive issue of yours needs to be recording due to legal reasons or whatever. And he would press a DTMF. He will press a key on his device. Okay. At this point, DTMFs would, of course, they can go through SIP as well, but most of them are going through RTP. So in order to detect and intercept this DTMF, only RTPProxy can do it. And it has some hooks, detects the DTMF, sends it back to OpenSIPS, and then we instruct RTPProxy to copy the entire RTP stream to a new SIP entity, which is CP recorder, which essentially is a SIPREC SRS, SIP recording server, which gets established a new call over SIP, and the RTP stream is being forked, very important, one way. So the recorder is not generating any traffic. But it's not only that, it also gets some metadata about the call. Who's involved in that call, who's A, who's B, what is the actual call ID being, the call ID of this call, and so on and so forth. How many of you know what SIPREC is? Actually, who doesn't know what SIPREC is? Okay, so there are a couple of you guys. SIPREC is a generic method of recording calls. So, of course, you can get the recording of the call through different methods. Here in RTPProxy is able to grab all the RTP and dump it in a file that you can post-process and listen to the actual call. But this can be easily done if you own the entire infrastructure. However, if somebody else is interested in your data, it has to be a protocol, a standard, to discuss between this infrastructure, which is mine, and this infrastructure. Imagine here is, I don't know, the US government who wants to listen for some calls for statistics purposes. Yeah. Right? So you will need a generic or a standard way of interacting between two different infrastructure. And we have SIP, we have RTP, which are pretty standard, but we don't really have the context. We don't really have the metadata. That's what SIPREC is. So it's a call with media and some metadata about the participants of the call. We will see a bit later. Okay, let's get started with. So for this lab, we have several, as you see here, we have several components. And in order to make it easier for you, or actually for all of us, to use it, let me increase the font a bit. Okay, it's better. Can you see? Yeah. Okay. I've created a Docker Compose file. It consists of a few containers. The first one is OpenSIPS, which uses a specific SIPREC instance. That's because SIPREC is in a different package, and I had to rebuild a new image for that. A configuration file, and we're running everything on the host just for simplicity. I'm actually running on localhost. Next, we have RTPProxy, which is configured with the catch DTMF module in order to be able to intercept the DTMF and send a notification to OpenSIPS whenever that DTMF key is pressed. And we have CP recorder, which is a new component Maxim built for an SRS SIPREC server. It's based on the CP stack, CP B2B stack, and it has a few. It will be listening on port 5090. We have here some UAI that we can show you, and you can use in order to, let's say, tune different stuff on the recording side. And it uses RTPProxy in order to catch the RTP and dump it in the file. Everything else is just settings. Where to use the spool and where to store the recordings. And finally, we're using RTP. We're using FreeSwitch just for terminating our calls. So somebody to be there. I could have used ChatGPT, but you've seen how responsive it is in this special network. All right, so we have these four components, and the fourth one that is actually not needed, I just use it in order to terminate my calls and be able to do recording easier. Let's see what has to be done in OpenSIPS. Actually, this started. I'm starting from the default configuration file. So this is OpenSIPS configuration file, but I've previously added some configuration in order to implement this specific scenario. Let's do the first thing to do is, of course, get the RTP to pass through RTPProxy, and for that we need the dialog module, the RTP relay module, RTPProxy module, and of course configure the connection to RTPProxy. Of course, we also need a special socket where we need to instruct OpenSIPS where we will be receiving the DTMF events, right? So we specify that as well. Go ahead.
Oh, just a note, with RTPO we can obviously remove all this.
Yeah, that's right. As Maxim also noted, we could have used RTPIO, which is essentially the embedded RTPProxy server into OpenSIPS, so that we wouldn't have needed the third container or the second container, the RTPProxy container. We could have configured it in RTPIO and everything would have run in this specific instance. But it took a lot of time to compile the image with all the modules that we needed, so I actually moved forward with a separate RTPProxy instance. But we could have done it with the new RTPIO module. Next, we need to configure SIPREC, which relies on the B2B entities module in order to generate that second call to the SRS. And that's it. These are the modules that we will be using. Here in 2.3, we just create the dialog, which is required for the RTP relay module to work properly. Instruct RTPProxy that we want to catch the DTMFs, so we use the D flag for that, and simply engage RTPProxy. We also store in dialog values the caller and the callee. That's because we don't really want to lose them throughout our call. So we want to have them from the start, so we can, whenever we want to engage the recording, to know exactly who's the actual caller and who's the actual callee. Here I've done an ugly hack, I would say. So instead of doing a smart choosing of the free switch, I just send it to the free switch instance I've previously configured by forcing the port, because I know it listens on port 5080, and I will just be sending calls there. And basically that's it. We'll go through these two routes a bit later. Actually, let's do it now. Yeah. So the way it works, whenever RTPProxy detects DTMF, it will send a notification at the socket we've previously configured, and then which will eventually trigger this RTPProxy DTMF event. So whenever one of the participants presses one of the keys, we will get this event. And what we're doing here, we're saying that if the digit is not 0, because we will only be using the zero DTMF code to toggle the recording, we just return. Then we want to determine whether the caller or the callee pressed the key, because we want to start different sessions for each of them. So, for example, if the operator wants to record the entire call, we will start a recording session. But if the other, I don't know, the client just wants to record a particular, like a smaller part of the code of the call, he would press himself zeros, and each of the parties would have basically different recording sessions. Here we will be using this. Actually, this is not correct, because what we need to do then, SIP recording relies on the dialog module to run. So we need to load the dialog context, because normally this event route is not triggered in a particular dialog context. It's just a generic event that provides information about the dialog that it's been triggered in, what digit has been triggered in, and what's the direction, the stream. But we need to have a dialog context, so this is what we're doing here. We're loading the dialog context and then simply toggle the recording. This should have been here. And it's one. There we go. Now, when we get this route triggered, we first want to see whether there was a recording session for that participant or not. So that's why we use two different dialog variables. One is recording caller and the other one is recording callee. We built the dynamic name here and check if the recording was true. This means that when the 0 key is pressed, we want to stop the recording for the caller, let's say, instance, and set it to false. Otherwise, we want to start it. We set the participants, caller and callee here, and then simply start the recording by sending it to the SRS, Sippy SRS recorder server, which is listening on port 5090. And we're also instructing that we're using it for the caller, or either caller or callee, because as you can see here, this toggle route is being called with the actual participant that pressed the digit, and store the variable as true. So basically, this is all I've prepared for you today. But of course, let's give it a spin and see how it works. To do so, we should start an SN grep. Let's make it a bit bigger. I think we will be C, and simply run Docker. This will take a while. Apologies for that, but my computer just restarted. As you can see, I have 24 after charging it. It died during the previous presentation. As I said, I'm just presenting a few tools, but you can, of course, use these tools to create all sorts of features that you want. For example, you can catch DTMF and, I don't know, put the call on hold or playback something to the customer. You can use it to block or unblock DTMFs, for example, if you want to have like PCI compliant calls from the bank or stuff like that. So it's just a bunch of tools that you can use. Likewise with SIPREC. SIPREC can be used in various scenarios, but it doesn't have to be SIPREC. It can also be media exchange, like we've done earlier. For example, you can have a digit pressed. When you press a digit, you can push that call into a three-way conference and start, I don't know, whatever applications you would like to. This is just an example. All right, it started. Let's run it. Okay, free switch started, CP recorder started, RTPProxy started, OpenSIPS started. I think we are ready to make a call. Link. I'm using Blink this time. Let's put it here. And I can call anything. So here, oops. Not sure why it's not saying anything. Okay. So I'm just talking to free switch now and nothing happens. As you can see, it's just like a regular call. But at some point, I am pressing 0 now. So once I press 0, you see that there's another call started. Sorry. There's another call that started. Let's see how that looks like. Yeah, OpenSIPble is great. I can confirm that. This is a call that started from OpenSIPS, and we will check the media. So as you can see, the media is just one way. There are actually two streams, one stream for each participant of the call that are being forked to this SRS. Let's do something else. Let's emulate a DTMF from free switch side. I'll send the same 0 from the RTP engine, no, RTP from the free switch side. See, it started another call. This call is being recorded from this specific moment, right? Likewise. Okay. And then we want to terminate the free switch call 0. You'll notice a buy that is being triggered by OpenSIPS. This one, actually, this one stopped as well. Okay, let's stop it as well. I think we need to check the tags, Max. There you go. Press another 0, stop the recording, and so on and so forth. Okay, let's see what we've got so far. My call is still running, as you can see. I can hear. We can see the DTMF events as well. These are the events that we've pressed. Here was my initial 0, then it was free switch 0, another 0 from free switch, and then mine. So all of them are caught as well in SNGrep. Let's terminate the call. Okay, we should record our recordings. Here we have the files for our calls, right? These files are, I think this was an attempt I used earlier. Let's remove it. Okay. Actually, these are the 2 legs of one single call. I'm not sure. I think the multi-leg recording doesn't work right now. Max, we should look into that, but it's probably something in OpenSIPS. But I will check that. We've got here a recording. RTPProxy recording this, and you will see that what it does, it simply takes all the pickups and put all the RTP packets and puts them in a pickup file. So we might need to use Wireshark in order to detect in order to listen the recording. However, RTPProxy provides a script that or a tool that can help us put this together and generate it in a simple file. It's called extract audio, where you can give it, this is the A side, the B side, and we want to generate a WAV file.
This is a question maybe more for Max. Does the SIPy SRS, have the ability to do like sign linear output, so for like real-time transcription type services instead of PK?
Yeah, it's coming. What I want to have is right now we just implemented basic schema, but I also want to have RTPO to be able to produce already either decoded or at least chunks of audio. So
that's really all, is the ability to ship raw audio, whether it's not transcoded, but just, ULA, ALA, whatever comes in goes out.
You probably don't hear, actually.
Just like
I don't know where I have the...
This is a call that started from OpenSIPS, and we will check the media. So as you can see,
apparently my free switch was louder than me. Sorry about that. Yeah, but this was more or less what I've prepared for today. Everything is in a public repository if you want to play with it. But again, I just wanted to show you like a few, as you've seen, it's just a few lines of code in OpenSIPS. Where is it? With a few lines of code, we've implemented something very, very easy, but can be extrapolated to things way more complex. I don't know, for example, instead the recording server might get the RTP and push it in an AI, which can do transcription, and as Eric asked, which can do afterwards transcription or interpretation, give you summaries and stuff like that. So the possibilities are very, very very, very dense. This is more or less what I've prepared. If you guys have any questions, sure, go ahead.
How expensive is that? I mean, have you compared the performance of the system where you need to listen to DTMF or when you don't need that? Do you have any load testing?
Load testing for detecting the DTMFs?
Like if I have like 10,000 calls, I'm just passing them with RTPProxy, or I'm listening to the DTMF for all of these streams. Any difference for this?
I think it's probably 0 because the thing is detecting the DTMF is just checking the payload type of the RTP packets. Like
So you have to listen them, right? You need to configure your system.
you have to if you have indeed to pass everything through RTPProxy. Yep.
Then you're configuring your proxy to listen to such events. Otherwise, you're just passing them through.
No, it's not listening for the event.
No, it's just wait. It's just a socket, and whenever a DTMF is triggered, it receives a packet. It's very, very inexpensive.
So RTPProxy inspect the payload type. If it's 2833, it sends an event over a socket to OpenSIPS.
Exactly.
And then OpenSIPS raises an event through its event subsystem, and it's like all asynchronous. So that it's 0.
Yeah, it's peanuts. I mean, it's very efficient. That's true. That's true. It's not detecting in-band DTMFs. No, it's RFC 2833, yes, something like that. So, which basically, as you've noticed, even SNGREP sees it as a DTMF, and it's just based on the payload type. So the payload type is 101 probably, and it's very, very inexpensive. Indeed, if we need to get in-band, that would be way more expensive. And I'm pretty sure RTPProxy doesn't do that. Can you confirm, Max? You're not decoding in-band DTMFs, but I don't think anybody uses that anymore, to be honest. I mean, most of the devices I've seen either in-band or out-of-band, like SIP info or SIP notif. Yes, but instead of yes, of course, but instead of having an event from RTPProxy, because RTPProxy would not get the SIP invite, we just need to code it here. For example, if it's method info and I think event is DTMF plus relay, or I don't remember exactly how the. So if we detect that, we extract the DTMF and do the same thing like here. Yeah, so it would work, but we just need to readapt it to a different logic. But yeah, sure, because they will go through the proxy this time, not through RTPProxy. Another question from Eric. I'm using Awesome. Awesome, yeah. It's awesome. I think it's, yeah, awesome.
With the transfers, I think you need to add a bit more logic.
For the transfers?
For example, if you are an agent and you ask to transfer the call for the supervisor, and it's like on the recording, and you are just passing it to the supervisor, so you're ending your session, so but you need somehow to...
Yes, that's true. I mean, the entire, that's why actually I haven't showed you. That's a good idea. That's a good question. So SIPREC consists of SIP, which of SDP, which has the 2 participants being involved in the call. We have one media session for the caller and another media session for the caller. I don't see it. I don't see it. Oh, it's here. It's here, yeah. So we have 2 media sessions for each participant, but we also have the metadata, which metadata that it's an XML that contains a lot of data, and you have recording session IDs, which is different than the call ID itself. So basically what you can do is, indeed, so as Igor said, when you have a transfer, for example, you're talking to a client and you want to transfer it to a supervisor or something, you'll do a refer, which essentially would result in a different call. But the recording session is the same. So what you would have to do is to start a new recording session, actually not a new recording session, a new call, but with the same recording session, which is this one. So essentially just putting another participant. It would be the same if, for example, you would have a conference room, right? A conference room has multiple participants. Each of them will have to have their own, the same session ID because you have a single conference room, but different participants into it. You can get the recording session, but you currently can't force it right now. But as you said, it's probably a requirement in this scenario. You can, of course, match it on different other. For example, you can add some headers here saying that this is the correlation between the first call and the second call. Catch this in the SRS and implement some logic over there. Actually, this is how we're doing it right now. Not we just provide but there are recording solutions that are doing it, and I'm pretty sure that the CP recorder might do it as well, like match the SIP. But this is the standard way, is, as you've said, use the same. To be frank, I've never, actually there was only one instance that we've implemented where they actually had to use SIPREC to a different provider, different company. But usually, whoever uses SIPREC, they use their own SIPREC solution just for them. So it's still their infrastructure, but they rather have it on a separate instance rather than have RTPProxy or RTP engine dump the. It's easier to manage, like having a separate instance. And more secure as well, right. There's another question, Max.
One more question. I think you might be a little bit, I think RFC, I might be wrong on this, but I think by RFC those labels should be indexed at 1.
I don't think there's anything in the standard.
You can check maybe.
I can check.
All examples I saw start with 1.
With 1. As far as I know, they don't need to be integers. They can be anything, as far as I know. So if that's it, just to be unique, that's it.
Another thing that I see you using hard-coded boundary of 42.
Where?
Like multi-part mixed boundary. It should be actually random, I think.
Oh, the boundary.
Yeah.
It's hard-coded in this one. Is hard-coded in OpenSIPS, but can be anything.
Yeah, but by standard it should be.
It should be random.
Yeah.
I'm not sure, but you might be right.
But at least it's the best. I guess
It's better, right?
best practice.
Yeah. Oh, anyway, you have the boundary here, so as long as these two are okay, it's syntactically correct. But indeed, it's better to be. It's probably better to be. I'm pretty sure in OpenSIPS it's hard coded, like it's a define. Yeah. We can. That's not that hard to do. Any more questions? Well, thank you so much then. I think there's a break now. It's lunch, right? Oh, actually there's no lunch. No, actually there's no lunch today, right? Is there? Okay. It is a break then. It's a break for sure. We'll be back here at 2 p.m. with another talk. I think it's Rita and Omar. I think so. If not, oh, it's Max. You're next. Check the schedule, guys. Sorry, yeah. Thanks for being here. Thank you.
Just like Gutman's. Okay,
Sure.
Sorry.
Go ahead.
What I was referring to, so imagine that you're having like it's an agent. Caller.
Yeah.
So caller is like having a, so then you're having an agent, having this SIPREC and SIPREC, like for the both lines. And then you're having like, you're sending the call to the supervisor.
Yeah.
Usually it's like the second call.
Yeah.
And then you're sending like refer or invite, replace or something.
Reinvite, replace, yeah, different.
But is there any way, because I did not get this, can you somehow to keep, let's say that these calls were recorded and then just like enforce the continuous recording because client had not touched anything?
Yep, right. No, so in practice, this call will be terminated, and along with it, the recording
as well.
session.
That's what I
No,
was...
you can't keep it. However, this is what the standard says. In the second call, you should provide the same recording, SIPREC recording session. So the same as I showed you. This.
But how can you? I mean, in the same call means this session ID.
Yes.
So it's something randomly generated, as I got.
It's currently randomly generated, but you should be able for the second call to provide the same session ID. We currently don't support that in OpenSIPS, but it's not that hard to implement. It's just we didn't think of this. But essentially, you will have indeed two different SIPREC calls, but referring to the same session ID, because it's more or less the same as I said earlier. It's the same.
Can you show me start SIPREC means when you're starting? No, in a configure for
Oh, yep. Here.
Yeah.
So here.
Yes, start recording, and you're just sending like. So
I'm sending to the SIPREC destination.
Yes, but there you don't specify any recordings ID. You don't specify any like.
This is what I'm doing here. So there's this SIPREC variable which.
Okay. So you can specify like if it's not explicit, then selecting.
Exactly.
But then after
this has some
recording, you can sort of store it in a dialog.
Yes.
bar.
Yeah, it is. It is.
And then if it's recordings, then we understand here, like on OpenSIP, that it's being transferred, and then we can force check if there was a SIP record.
Exactly.
Okay.
For this, because when you get a refer, you know exactly what core you'll be referring to.
Or reinvite. Okay.
Or reinvite. Yeah. There's this. Not sure if it's in. So with this, I think it's in. I added it in 7. No.
Session custom extension.
I'm pretty sure I added it to be accessed because we had this this problem.
But maybe just.
It's probably not documented. No, let me see.
As I got also just a question, like lunch is not provided, so we're on ourselves.
Yeah, I think it's not provided, to be honest. I'll check.
Okay. No. Just a question. I'm growing up boy, so we need to find something. Sure.
I don't remember exactly how it was implemented, but I'm pretty sure. No, actually, yeah, it's something else. It's exported in the events. Now I remember. It's exported in the events. Not here. Here, session ID. So there are some events when the session starts. You have this event, and you can store it in a dialog, as you said. And then, but you can't provide it. And what the ideal way to do it is, for example, to have like a session ID that you can store in the SIPREC before starting, and instead of generating, just read it, and that's it. It's quite simple to implement.
But it's not yet. Like.
It's not yet, no, but it's easy to. If you open a pull request, I can do it probably by the end of the day.
Okay, thanks.
Okay, sure. So.
use programmatic techniques. They are available.
Days are getting longer
Like
when you're in
parameterized queries.
Amsterdam.
So you don't have to do any input validations with parameterized queries. Because it knows already, hey, this is an integer.
Your sausage was
The whole problem of building strings from one format to the other, that's always troublesome. But that's how we do things, right? We use complementary and
Those things are frequently when you are typing something and creating something and then validation, that's the first thing you have.
But sometimes what happens,
That should be the first thing.
we also have a billing
Security
service.
first, but
Yeah, I mean,
it's already better than 15 years ago.
for security you need to see
Yeah.
that things work, right? So
You have that.
you know, but the
Yeah,
problem
I mean,
is that once things
we are
work,
the-
we're so happy about it that you want to ship it.
Right.
I know because I'm
Yeah,
guilty
sometimes
of
we
this
have a
myself,
customer
so-
who comes
It's
to
human.
You want to pay something that has to be
either
fought.
CTDS or
We're
maybe
not
who wants to
robots.
migrate to
AI
CTDS
is
as well.
So that might actually
Yeah, that's good, you know, it's a small market. And
Yeah,
I
but it's,
believe I have got a very good
parser
feedback
goes to
from the
AI and
customer.
say,
Yeah,
give me
exactly.
the
You
flow
would,
set.
as part of your system
Oh,
prompts,
thank you.
you would always have
Well,
it,
we don't do
you know,
similar
do
things
a security
because,
audit before
Yeah,
you.
yeah, and he can do it
For
or
us,
make all the
we are
regex because that's a
creating
boring
just a
job.
part of what we
Or
have.
that,
Creating
or that.
regex is a boring job.
It,
More and more
and it
come
needs to be
with
specific to
IMS
your use
solutions.
case because and not introduce problems, right?
Yeah.
Sometimes you need
for IP management,
a single
for radio
purpose, for
stuff,
example.
because the 6G,
so the right
5G
way is to
really
escape, not
So I don't think it's really
Not at all, not at all.
It
But see, our main
So it depends on
class 4, class 5.
if you do
it's
or
completely
talk with
different
OpenAI
Yeah.
about OpenSIPS,
because you have
blah,
an
blah, blah,
integrated solution,
it's hallucinating all the way.
especially for
Including UI,
It's creating functions that never exist, that should be,
okay.
it should be nice to have them, but it does exist.
Yes,
So,
we
but
use
OpenSIPS
Shlomi
to
was
scale up
busy
the
with
system.
creating an AI assistant,
So we
trains
make a
on
cluster
all
of
the
it
OpenSIPS
and
documentation.
a lot of
yeah, they mentioned it, yeah.
That would be nice to have in.
so many, we have
Then you can just
many
prompt
customers
making a
in
proxy,
Africa
maybe
Once
whatever.
you do that,
UK, US, who use it.
it starts anchoring
I heard about
stuff
it before.
because it's as
Yes,
you can
yes.
with Gemini you
Same
can
here.
put a lot of documentation in the prompt
Then,
itself,
yes.
you know, and it makes
So
a huge
it's-
difference.
Yeah.
It really fixes a lot of stuff.
And I think there was a,
We
the,
can
the,
also add
the manner how the documentation is built, there should be something changed then to make it readable for
Yes.
AIs that can link
management
to URLs.
Yes.
So it can really
Like
find, you told me that,
Yeah.
but I'm not familiar with
resources,
We-
channels.
We were discussing,
outside of,
for
like,
example,
in a centralized
creating
way,
bad
because
examples
we have
and
many
correct
switches.
examples.
Yeah.
Each
So that
are emitting on their own box, but
But
you
it's
have
a
a centralized resource server, then you can control the free switches in a central way.
interesting data.
So it's all these modules check them out, but they are
It
many.
makes
Okay.
makes
We have
our life
500,000 lines of code
interesting
now.
again. That's how I feel about it. It's like, yeah, okay, finally something challenging or different.
Someone asked me recently, does AI make it like
Others
easier? I said, no, it's probably different.
Yeah.
It's useful sometimes.
Yeah, but
Definitely.
we're still in the
Try to
beginning,
see
the
how we
beginning days
can,
of all that stuff.
I
I mean, 1 year or 2 years.
You can do extensions.
We're still at the
because it's
beginning.
API based.
But the
And
problem
also
is,
what you
you're in
can
the
do
beginning,
is
okay, but
send the
everything is
CDRs like this, so
moving
ER
on
is
very,
just
very
example,
fast.
but you can
Yep.
call
If you
APIs.
compare it to the
Because you get the
let's say,
CDRs from free switch, call APIs on our side,
96,
and
the
at the
internet
same time, you
It took like slow 5-6 years until everybody was on
At
the
the same
internet.
time, you get them
But now
already rated
AI is
from the
coming
rating.
and 3 months
Then
later,
you don't have to
almost
rate
anybody
them
is jumping on AI and
That's
doing
how it
stuff.
feels. But
And that's not perfect. This
No,
time
no,
it's a
SQL
spielerei.
yeah.
stuff.
But
It's
it's getting
there's a
more
lot of
like,
times, yeah, for sure.
All like them would take
Yeah,
no database.
no database,
See how
and
we can
you
Yeah.
have shown that to process 2 million,
You know,
yeah, it
I
took
was
like 10 minutes, right?
getting
Yeah,
really
well,
tired of all
my machine was
usual
slower
stuff,
because
you know,
it's laptop,
more
but It was
work
like
that is
15,
grinding,
14 years
you know,
or
like,
something.
Yeah.
no, this is
Like I mentioned before, it's a new era of security, and that's nice because we already lived for 30 years in the same security export.
it uses the CPU, right? When I started, you know,
that's
like,
what happened actually. Because we have a lot of
25 years
services
ago,
running in the
officially,
background and
I mean, it was really exciting.
I mean,
You know, we could write an exploit for Windows.
There were no regulations.
Yeah.
There were very few regulations.
It started in 2000, 2001,
So Launch is provided same as yesterday. I have no idea either, but yeah.
Okay.
It's just not.
The other guys, they know or they went outside?
I don't know.
Let's go get
I
some.
don't know. Probably
It's-
I was distracted as well.
It's
So
downstairs in the
yeah, in the same
same
as yesterday. Yeah.
Because I have the feeling the rest of the people, they went out for lunch because they didn't know it's provided.
Then we can eat more.
Yeah, we there.
Yes, we can compensate.
So for me, I would be very happy if you use parts of
Okay.
this. It doesn't have to be all. All you need. Actually, it's open source. So
yeah, of course. I'll try to find a way, like how we can do it, you know.
just it's open source, like he said. Steal it.
Of course.
So,
Yes.
what I didn't ask you earlier, hopefully because you demo the platform, what would be your...
Oh, there is no lunch today, so you can just go and get some.
What is it, lunch now?
There's no lunch today.
Huh? Would you recommend using the module environment?
Maybe a chapter.
It depends on what
But I
you're
think
starting
people
with.
just went around.
Because if you have to do
Oh,
like
maybe there is.
ingredients,
I got my numbers here, 4 million users, not 600 million users, so check.
it's still okay. It's
But
impressive
yeah,
number of users.
it's a lot of users. But they are spread across 4 geographic regions and then like 60, 70 VMs per region. So it's not, when you look at one individual node, it's not that busy. So I think in an ideal world, if we had some cluster of a couple of CDBs instances, and we just use the OpenSIPS module to fire things straight into that, then that would probably work. But I was wondering whether that, or is it better that we, because we don't need it in real time, so is it better that we export it to flat files and then process it we demo today? Or
Yeah,
do you
normally-
think the module would be better or quicker?
I think if you ask me, flat file would be faster.
Right.
Because even on OpenSIPS side, you can even, I think, restart OpenSIPS during the call, because the record will be still written. So by after that, if you restart an OpenSIPS with a session on it, it's a bit, so it needs to be dialogue aware in order to write CDRs all over the network. So I have the feeling.
I think we're using the dialogue module because we're doing topology, so it's stateful
You need
assets
it, yeah.
and it needs to be there. I don't care about registering when we send without. So because we're middleware, we're the wrong way around. So people don't register to us. We send registrations out to PBXs, basically pretend
You
to
want
be
to
a
go?
phone.
Yeah,
go get some lunch.
Let's go together and discuss on the way.
So we.
Hello, and thank you for calling Sippy Software.
think I screwed it. I don't think currently RTPProxy can support multiple copy, right? Commands.
Not at the moment.
Not at the moment. I think we discussed, but I completely forgot. That's why my
Something didn't work?
Yeah, because I started 2 sessions and only recorded 1, and then I remembered that. But yeah,
we need to.
Yes, it is. It is. I mean, we've actually developed this for somebody that needed it. So. Yeah, and it's probably harder to do backwards compatible as well, but we'll see. Something like that.
I also improved, one of the problems with the current code is that it would first allocate some random port, which is itself okay, but
I think you fixed that, right? I didn't.
Yeah. So one problem that it would allocate it totally random outside of the configured range. So if you especially with Docker, it's obviously important if you
you have the forward
the window.
Just those forward things.
So that's I fixed. So now it should allocate from the same pool. But then the other problem, yes. Yeah, we need to have a port. I added flag, so basically you can add S flag to the copy command or second P flag, and it will give you exact tuple of labeled port number. Yeah. So then you can just stick it to the SDP.
I'm not okay. Because I think, I don't remember exactly how it's implemented, but you first need to get it. I mean, you don't know it when you send a copy.
Yes.
No, but imagine you have to build an SDP. You don't have the remote entity, so you have to send a copy.
Yeah, you send the copy. You get the tuple back. You put it into SDP. And you send it to the recorder.
Yes, the recorder gets you the destination, and then you have to call copy. That's the problem.
Oh yeah, you mean we got.
So it needs to be a command to allocate it and the command to use it.
I'm thinking why I'm not having this problem. Because I also have client in my B2B, and I did not have what's how it called.
I think you might know the destination before. You can know it because it's randomly allocated on a SRS, right? The port.
Yeah. Yeah, I need to.
Yeah, let's double check. But finish your workshop. Your
Yeah.
And
I'm
then we
thinking.
can check.
I was thinking if I'm going to set up this, maybe I won't have time. So.
You do your stuff.
manage to get it work?
Let's see.
So maybe you know, on top of your head, like this here, when I try to play, I get this error.
Yeah, sure. To me, I think about the or two parts. One where there was about AI integration. Darius. And then the next one. Yeah. In fact, that was a Python script connected for using OpenAI. So because of that, I have local models.
Very general. Maybe it's a good thing to SIP search. SIP search testing. Automated testing. So you give a good insight of how your system is giving alerts.
Is that open source? No, it's this one. I mean, you put it with. Because I think it doesn't find.
After the second time. So it doesn't.
That's really interesting. Yeah. I thought it was really. It doesn't find the proper file with the proper body. Can you show me the?
Just regular wave file.
Yeah. And OpenSIPS.
Okay, I can need to convert it to the
No, it's not very sure.
Still it is. It's good.
So it's not. It's not because. Yeah.
it's good. It's good.
What?
Shall we start?
Yeah. Do you want me to do some introduction, or you just want to do it
sure.
yourself?
Yeah, I can do it. Yeah.
Okay. Then.
Hello, everyone.
You can open full screen.
Yeah.
Slideshow.
Yeah, okay. Well, hello everyone again. My name is Maxim. Again, if you missed my presentation yesterday, I'm from a company called SIP Software. We've been around for more than 20 years. I'm an author of few well-known tools like RTPProxy, NetHelper. I also did some other work on OpenSIPS. But anyway, over the years we kind of developed set of tools which some of you might have heard, but maybe some of them if you don't, which are less known than let's say RTPProxy or NetHelper, which we kind of now trying to kind of promote a little bit more and build hopefully to be useful. And I will try to show some of those tools, and hopefully takeaway of this will be something that you can use in your future projects or current projects, or just as some tools you can also employ to like on day-to-day basis to solve some issues like connectivity issues, because that's what we do with those tools. So for example, if I have some networks that I need to bridge quickly, I can spin like B2BA and just give it static routing configuration, and then it will take care of all like inter-network connectivity and stuff like that. I will show this in my presentation demo today. So anyway, first tool is that I wanted to kind of showcase and that we kind of updated a little bit recently is CP B2BA, and this is basically full RFC SIP stack with B2BA written in Python. It has uses some of the modules that I built over the years to improve kind of responsiveness and performance in C. So basically, pretty good project if you need like something, as I said, maybe you need to bridge some networks, or maybe you want to build some custom functionality. So basically, I'll show it in the terminal. Oops. Okay, make my screen bigger. Yeah, so basically the way this works is you can install it through the pip, so something like pip install in this case it's already installed. In this case I will basically have I will use it to show the VoIP test. So basically point it to the system itself. Just give me a sec, I'll copy configuration. Yeah, so basically here I have disabled the SIP login, so it does not litter the screen, and then I put it into foreground. Oops. Hold on. And then I enable the UI. Another one of those. Set the listening port, and also let me remove this test. I don't need this. Yeah, as I said, I turn off all accounting, authentication, and I just give it one static route to the local host, port 50,620, and set listen address to the asterisk and SIP port 5060. I switch control socket and set some parameters for the RTPPO module and set the SIPREC target. So now let's try. See that it's not already running. It's just a Docker, should be okay. Okay, so far so good. Seems to be running. So right now, before this version, it would just run, and this would be pretty much it. It could interact with it with the SIP or through the control socket. But as I said, in this version, we basically added a little UI. So now you can actually go to that. Oh yeah. So this is pretty basic at the moment. So here you can see like list of active calls, and you have access to the routing configuration. So you can on the fly change parameters like SIP authentication. You can change where it goes with the next with the call. You can change session timers and stuff like that, and you can apply changes in like real time. And then, as I said, it has some integration with the SIPREC functionality. So basically, once we get some calls going, you will be able to see some more actions here to basically activate that. So now what we can do with this? I wanted basically to show you also our VoIP test package. So now I have this B2B running. I can also run Alice and Bob in this on this machine and basically simulate some SIP traffic going. So basically I'll have Alice sending calls to this B2BA, and B2BA will be routing calls to this another port on the same system to the Bob user agent, which will answer them, and they will run some scenarios. So now, as I said, there is another project for that, which we use quite extensively and more in various situations. So, for example, I'm using it to test my RTPPO builds to make sure that they can actually work, not crash and everything. So what I do, I basically just grab the code. Okay. Oops. Okay.
All right, so now I have this repository here, and it's also based on our SIP stack. So I basically don't think I need any other additional modules apart from what I already have installed. So basically, let me grab some scripts to run it.
Sorry.
Yeah, I probably need to polish some of those scripts and make them more useful. So for now, just some internal stuff. Yeah, so basically here I have, I run this Alice user agent. I set it some CPS level. Also, this is enable IPv4 flag. I give it listen address. I give it port, UDP port for SIP. I give it port range for the RTP ports, some timeouts parameters, and SIP target, which will be, in this case, our B2BA. So now I can actually run it. Hope it doesn't crash. Okay. CPS. Let's put one CPS for starters. Yeah, 56, it should work. Yep. Okay. Okay, so now it starts sending some calls. So if I go back to our B2B interface, I should hopefully see them. Oh, and so yes, indeed, we see there is no BOP at the moment. So as you see, most of the calls are just hanging out in initialization until timeout. But eventually you can also already see that you can interact, so you can disconnect some of them forcefully even before B2B logic kicks in and does it. Another thing that you see, there is a live update going on. So basically we have JSON API being called, and we pull this data. Now, what I can demo here as well, we can show that this is reasonably fast. So now, for example, let's say we stop this. And this is like slow stop mode. It will try to wait for all calls to terminate, but you can also give it. I know, I cannot. It doesn't work like that. And I can nudge them a little. Die, sucker. Yeah, okay. So as you see, another interesting thing, what we use it for, we also try to see that we don't leak any Python objects. So we can basically, what I do usually, I have it running like 24/7 on some of my machines and check periodically that it does not leak any objects. Pretty important. But anyway, so as I said, I can here I can, for example, bump to 100 CPS, and now you see the counters really skyrocketing. But nevertheless, if you go to the something is maybe I was too soon to that. Still, I think it's kind of sluggish. Yeah, maybe 100 CPS. Well, you see it's already at 2000. So yeah, maybe 100 was a little bit too much. I frankly tested it about 30, but it was running on like a real machine. Right now, it's running on the VMware. So let's maybe dial it down a little bit, so we can hopefully still shut it down. Maybe not. Let's stop this madness. Oh yeah, it's shutting down. So, oops, that's wrong. Let's minimize this. Yeah, everything is went down. Let's see if anything crashed. Few tracebacks, but I don't think something fundamentally. Oh yeah, okay. Can't parse options. Can't find local address. Okay. Anyway, so this was like fun test, but now we can also plug in the other side. So now we can have like some real call establishment, not just one side. So let us start the BOP. Yeah, BOP. Okay. Yeah, pretty much the same deal. So basically set some parameters and that's about it. Start another session. Make this big and smaller. Maybe give a different color. This. Anyway. Start Alice in this one. Give it, let's say, 10 CPS. Check. How much CPU do we have? Okay, so 10 CPS, looking at 6% on this virtual CPU, so not bad. Now we can try to get Bob running. And I need to give it the same port that I use when I start my B2BA, so that would be, oops, it's the wrong one. Let's close this one. And that would be this guy. So basically use this one for the BOP. Okay, so now I have my Bob running. No calls yet because I don't have B2BA. So hopefully now I start it and we can see some counters. Not really. Okay, let's check the. Okay, no calls at all. Great. What's that? Port? What's wrong with that? Yeah, it's local port. What is listening on? It should be going to 5060. Yeah, let's debug it. Well, what we can do, we can run. Let's. No calls. I guess TCP dump is the next. Okay. Yeah. Okay, so now we had forbidden. Okay, SIPOP. So actually got calls flowing. So we got invite from 63, this Alice, and it invites SIP, and SIP for some reason is not answering us. So I guess I screwed up authentication somewhere. Let's see. Off. It's weird. Maybe something else went on port 5060. Oh yeah, I guess I have collision. I think that the Bob itself, I think it's on the, I think I butchered some arguments. This is our port. Okay, let's stop it. No, it should be. Okay, who is on 5060? No, maybe didn't try. Yeah, very slow internet. Alice, WebRTC. I guess my WebRTC phone might be on the port. Let's shut it off. I can just shut the Docker. Oh yeah, okay, so that was the culprit. Okay, so we have Alice, we have Bob. Let's try again to start B2BA. Yeah, that's what happens if you have too much components running on your machine. Okay, here's my... Okay. Okay, so now we see the calls finally. So getting through the B2BA to the Bob side from Alice, and okay, too many open files, so immediately. But you see the system is working regardless, hopefully. But let's see, maybe not. Yeah. So yeah, I think we need to dial it a little bit down. It's a fresh system. I have not really tuned it up for any ports. But regardless, it has been able to shut off. At least did not crash. Now we can dial it a little bit back. Let's get to the Alice terminal. Let's give it a quick kill. Yeah. So let's do like something sane. 3 CPS. Okay, so we have around 60 calls. Yeah, still working. Okay, and I believe the way we set it up right now, this kind of development version, it will ramp. It will not be like constant number of CPS, but it will ramp and up and down. So you might see some spikes and all that. But anyway, so basically the bottom line what I want to show you that now we have actually connecting. You can also use the other features. So if you specify SIP recording server, you can also initiate those calls. Some of them are short-lived, but you can initiate essentially recording sessions as well using this interface. And yeah, but that's basically the part on that I wanted to kind of demo on CP B2BA and VoIP test. So yeah, if you have some of those needs, check those tools out. They're pretty cool. As I said, we use them on various occasions. You can also use them for testing or for quick fixes or some production uses as well. Then what did I have next on my presentation? So next thing is our new RTPIO module. I don't have much really to display here. I just wanted to show you more on development side how you can access it, I guess. So for example, if you need some building some applications that needs to handle some kind of RTP traffic, it might be quite interesting opportunity to use it because what it provides kind of quite low level but still quite comprehensible language that you can use to basically describe your session. So, for example, instead of like all RTPProxy does is basically we extract all like important bits from SDP and convert it into very small kind of commands, which very similar to like, I don't know, assembly language for RTP. So basically you can build pretty interesting scenarios. So for example, I have, as part of RTPProxy, I can show you some examples. I have built a little kind of scripting engine to test it. And the problem I'm trying to solve here is that in order to test some advanced functionality with like with DTLS, ICE, and stuff like that, it's very difficult where you also need to set up like the whole infrastructure around it. So if we need, for example, to run a quick test of how we can decode DTLS, for example, or establish DTLS session in RTPProxy, we don't really want to have like the whole, like to set up the whole like SIP framework and exchange SIP messages. So what I built a little kind of little kind of scripting language which it's in the Python RTPL. There's a little bit even description here which you can find, and so basically the idea here is that you can express set of commands that I sent even to several different RTPProxy instances, and then extract important things from the responses and use them in building other commands. So this way you can build a sequence commands of RTPProxy commands that emulate, for example, DTLS session negotiations without having to set up the whole, as I said, infrastructure around it. And it works very well because we can, if you look at some of our test scripts, we can set up a bunch of sessions essentially and enable, disable DTLS on the fly, play some files and stuff. So kind of useful. But what I'm trying to get is you can now use this as part of your application. So basically with RTPEO, so for example, I go back to my terminal here. Yeah, so basically I can do import, I can even make it even bigger. I guess I don't have to. So basically all it needs is we basically initialize it, and then immediately we can use the socket. Let me see what's the name of this. It's not very well documented. It's very new, but eventually, hopefully, we'll get it. So we basically have this RTP sock, which is actual socket, a notification socket, which you can access as a Python object. So we can basically simple do this send. Oops. That's okay. Just do this. Which means 2 bytes has been sent, and now hopefully we can receive a reply. Okay, so that's the basic version number that reports. And yeah, as I said, you can do all cool stuff. You can set up RTP sessions, you can set up forwarding, you can obviously do all the initiate recording of the calls, you can do DTLS negotiation without having the whole like SIP package. So might be pretty useful. As I said, we have at least 3 or 4 different projects that is benefiting from this. So hopefully other people will find it useful as well. Okay, anyway, so we're kind of time runs out, so let's move on. What else do we have? So the next thing that I wanted to kind of showcase, I don't know if Darius is not here, right? But this is more if you do like something, if you're interested in actually generating sequence of RTP packets or consuming sequence RTP packets and producing basically audio stream out of them. So it's a little Python module, and it's born as a need to have this functionality for our Infernos AI framework. What it can do, it can basically help your Python script to generate RTP packets without much load. And it also, we don't have this in documentation yet, but I also added reverse functionality. So basically it will allow you to consume sequence of RTP packet and generate chunks of audio, which you then can easily feed to your decoder and get an audio. Yeah, as I said, the best way, if you're interested, there is some examples of how it's been used in Infernos project, so you can check that code. Yeah, we hope to see to beef it up a little bit more. As you see, this is published on both GitHub Docker container repository and also published on PyPy, so you can easily get it. Oops. Anyway, yeah, check it out. As I said, if you have the need to do low-level processing of RTP packets, might be pretty useful. Save some time and let us know if some improvements can be done. So next thing that we kind of this is CP recorder already I mentioned or showcased during the Razvan's presentation. Project that we started as part of the OpenSIPble just a proof of concept. Now we got some time to beef it up a little bit. I added better support for some scenarios, and in general made it kind of hopefully useful. So yeah, basically the same idea. Right now it's not Dockerized at the moment, but eventually we want to make some kind of useful Docker container out of it. Razvan actually already did, so we might use some of that work. But basically I have here some scripts. Let me switch to that. This one is closed. This one could leave. Let's start another one. Yeah, so here is the UI file, and the same idea here. We have some parameters for the UI port. For the SIP, we have RTPProxy configuration, which in this case RTPO, and we can hopefully run it and get it working. Okay, so it's 44.3.3.1. Let's open it up. Don't need. Don't need. So this that's the recorder interface. And now if I go back to my B2BA, which is still running in the background, I can simply click record and have some of those test calls connected to the recorder server. As I said, those calls don't live very long, so it should disappear in a minute or two. But anyway, so I won't go into much details. It's still a kind of work in progress, but if you find some use for it, let us know, send us patches. Code is not very complicated, it's just one file pretty much. So yeah, if you have some specific need, should be very easy to understand and get something going. Next, and I guess probably the last thing here I have is WebRTC phone. Basically what we did, let's go back to my real presentation. And so basically this consists, initially we started with like 3 separate components. So we had SIP B2BA, we had RTPProxy, and HTTPD as separate entities. And in this revision, I have integrated all of them. Although you can still have like RTP externally, it's just an option to have it as part of the B2BA, and the image is fully containerized. We built for 6 different architectures. So I have not really got a chance. I was hoping to demo it on RISC-V, but have not really got time to do it. But it's all automatically published, so if you have some kind of those systems, you can play with it. There is pretty good, or at least decent configuration documentation on the GitHub. Whatever, no, WebRTC, I think. WebRTC phone. Yeah. Okay. Yeah, so basically it takes, I was pretty sure this, maybe I was too quick about the documentation. but in any case, it takes several parameters. I need to build this up. Note for self, but essentially, if you go to the run file, you will see there are some parameters that you can pass it, like RTP port, min port, max port for RTP, VSS, HTTP, and so on file. But long story short, basically I have pre-cooked configuration here, which I can demo. Spin another terminal. And so here we have configuration for the container. So I give it min port, max port, log level, some version of the RTPProxy, because we pack 2 versions, debug and non-debug. So this is no op actually if we use RTP. Then outbound proxy and SIPREC target. And basically that's all we need. Basically it can be run actually it will conflict with that guy on SIP port. Let me shut it off. So I'll shut it off. B2B started earlier because it uses the same 5060 port and I don't have time to reconfigure it. So yeah. Okay. Okay, hopefully. Okay, well, it's already get bombarded by the Alice with some test calls, which is interesting. But it got started, so now if I go to that, it was port number. I think it's just 443, I guess. Yeah. Yeah, so basically we have a similar style interface, and here we have pretty much this is stock at the moment SIP JS front end page, which I hope I will have some time to modify to make it more useful. But anyway, so here we can basically connect to VSS, which is, as I said, in this case, going to be CPB2BA, and we can hopefully place some call, which I configured. If we go, I'm not sure if audio working. Oh, it's better working without.
Select one of the following options. For sales, press 1. For technical support, press 2.
Yeah, but now if we go, we can also use active calls interface of this WebRTC Docker instance. We can also do like disconnect the call and what I also want to show routing. Yeah, so this call actually I have configured to route our source switch in the AWS. So basically it sends call there. Basically it proxies between VSS locally on my Docker container and sends it over for termination. And probably the last thing, as I said, there is web SIPREC integration. So now if I play the call,
Hello, and thank you for calling Sippy Software.
now we can go and start a recording as well.
Select one of the following options.
And so if I go back to the SIP recording server, we see the call is connected here. And we can disconnect it. Okay. All right, so that's the WebRTC phone. Again, if you need something like this in your project, it should be easily available. We publish, as I said, container for multiple architectures, and we hopefully will be able to build some more useful features into it in the future. And the plan is to integrate it as well with our AI framework, so we can use it to basically directly connect to the model and use it there as well. I have not really got a chance to integrate it yet. I was hoping to, but that's as far as I got. And yeah, I think that's what else. Yeah, it's the last slide, so we're about on time. Any questions or anything?
Questions? Coffee break? Or straight ahead?
Okay, so we have like 5-minute coffee break, or stay around. We're just plugging things up. We'll start in 4 or 5 minutes.
Okay.
Cool. And then we show the epic. Then for whatever level, you'll find
That's happening, all the metrics, logs, traces, profiling even, on GigaPipe. I don't know if it is production, I hope so, but... Okay, before we go into a dangerous demo, apparently, let's do a quick recap on GigaPipes. So GigaPipe, as you know, polyglot observability solution for all your logs, metrics, traces, profiling data. It speaks Prometheus, logs, Loki, Tempo, Pyroscope, OpenTelemetry. You guys already know. But basically, what does it mean? It means that you don't need to pay for Datadog, Elastic, Grafana Cloud, and all of these. At the end of the month, you have one place to go to troubleshoot it all. Really good, I know. So how does it work? I hope you remember this beautiful diagram. This is the high-level overview of GigaPipe. Again, telemetry agents. You inject anything or everything into GigaPipe. You deploy it as you please. Again, Kubernetes, Docker, Podman, directly on the machine. Doesn't matter. It's compatible. And you kind of can store it as you please too. But currently, it's true, the open source GigaPipe is still working using ClickHouse. So all that I discussed about the Parquet files, it's still work in progress. Probably in the summertime or, I don't know, fall, we will deliver it, but this is not official. I'm just winging. Let's see what happens. But yeah, so currently the demo and everything that we are going to show today is using ClickHouse as the database in the quote-unquote normal way to do it. Okay, from some feedback that you guys gave me about the presentation and from the questions that you made, it seems that this magic of GigaPipe is still to be cleaned out. Like, you don't understand how it writes and reads, so I'm trying to attempt to bring some light into this. Again, GigaPipe is open source, so you guys can go and reverse engineer it, but hopefully this will give like the entry level for you to understand. And we will start with the writing. So you ingest the data, the telemetry data into GigaPipe, and then what happens? So it writes. But the truth is that, as you may imagine, it doesn't write directly to the database. It doesn't go and insert into ClickHouse directly. Some stuff happens, and it starts with the controller. The controller is the entry point, and it uses HTTP handlers to receive, well, either open telemetry, the prompt tail, whatever you are injecting. And basically what it does is accepting your data, parses it, and performs the compression if it's needed, and basically dispatches it into the parsing, which is the marshal. Actually, by the way, I don't know if it was clear, but you can scan this QR code or go to this URL to see all the files in the writer, or all the files responsible for the writing task. And each step, I have the folder where you need to look. So on this case was the controller. And after the controller, the HTTP handler, we have the marshal, which is the parsing. So basically here what we do is parse the format-specific telemetry data that you send. Again, according if it is logs, metrics, traces, whatever it may be. And we convert it into be GigaPipe compatible according to the GigaPipe infrastructure. Not the infrastructure structure, sorry. And then we parse it into chunks to be sent again to the controller. And the controller then, okay, will dispatch in chunks, as I said, depending to the service that you are trying to use. It prepares to be written to ClickHouse, the database, organizes by tables and by schema. And the point here is that when you write, the default is to write every second. And it writes in chunks. But you can customize this to write according to your setup, let's just say that. And the specific files that you may check for the writing into ClickHouse are these two that are highlighted in purple, the insert ClickHouse client and the general purpose ClickHouse client. Everything is in Go, yes. Okay, and now how do you read? For the reading, we have 5 steps. Step number 1, request handler, the reader on the controller. So an HTTP request comes in, depending on this, if it is logs, metrics, traces, profiling, whatever. And basically the controlling will validate the request and the headers and route the request to the appropriate service, depending on what you are requesting, right? Then step number 2, delegation to the service, depending on the request again. So you will extract the ClickHouse connection info, route the query, and manage the execution of the query and post-processing of results. Step number 3 is the transpilation, and this is actually the brain of the reader. We can call it that. So depending on the query that you have, what will happen is that the SQL statement will be validated and a list of post-processing functions, depending aggregation, formatting, the labeling, merging. So again, the labels is the way to correlate the data, and the labels is what you ingested. So just to be clear, the labels is not a magic on the reader, it's a magic on the writer, and depends on what you said on the agents. And then we have step number 4, query execution, right? So you do the query, and again, everything is handled in batches or chunks to have the best performance, let's just say. And then you have the response formatting. So this was super simplified for you to get the overview of it. So it's modular, it's not one step does it all. We have multiple steps on. And I mean, again, open source, you can check it, but hopefully with these details, you are able to go to the file that you desire to check. So now that you hopefully understand more about GigaPipe's functionality, let's just remind our colleague that there's always this colleague that says, you know what, but why should I care for GigaPipe? I already know how to troubleshoot it all. I'm that good. Yeah, okay. So you are wasting time and your team's time. If you have this colleague, I'm sorry for you. I don't know what to tell you. But hopefully you work in a nice place that you don't have to endure this bullshit. If you don't, I mean, maybe QXIP can take a look at your CV, I don't know, maybe. So anyway, let's check some stuff in real time. As I said, so the Parquet explanation from the presentation is still work in progress, and it is actually part of the Omer 11 work. So hopefully summer, fall, I don't know, let's do our best. Maybe at KubeCon I can actually demo Omer 11. I'm hoping for it, but today it's a GigaPipe only party. So for the next slides, the most important is the OSS demo. It's what we are going to take a look. But you have also the documentation and the GitHub repo. So either the URL or the QR code if you want. And from a demo. So on the demo, you will see that it will be more services than these ones I'm showing today, but those services are yet more examples of what you can achieve or how you can insert data, traces, logs, metrics into GigaPipe. For the simplicity of today, just to understand one more time, I'm just focusing on one, which is Halloy. So Halloy actually does it all. It generates data, it scrapes it, and sends it. So all of this demo will be kinda Alloy is the agent that does it all and sends to GigaPipe, and GigaPipe is where you will have everything to be able to troubleshoot. And we will use Grafana to see the output. Okay, so if you go inside of the demo, if you didn't have time, you still have the QR code here. So to see how traces are configured, as I said, everything will be inside Alloy. And you have here the snippet of the code. So basically, those are tempo traces that are being generated by Alloy itself. And then we will just send it to GigaPipe. So, of course, Alloy does it all. It's really simple. This is just for your comprehension. Metrics, same thing inside Alloy. So you have here Prometheus metrics. It's what we are scraping, generating, and sending towards GigaPipe. Then we have the logs that are Loki, generated again by Alloy, but are sent by Loki towards GigaPipe. And then we have the profiling data, which basically what is happening here is a bit longer than the prior ones because, well, on Alloy we are self-discovering the containers and scraping for eBPF metrics directly from Alloy, and this is profiling data, so we are using Parascope. And we send towards, actually on this one you see here, we are not sending directly to GigaPipe, we use the hotel collector. Eventually we are planning to be compatible 100% with profiling data, so in the next release or in the, I also think that the open source is fully compatible, so actually I think you guys could put here GigaPipe instead of the hotel collector, but on the commercial version we still need to make it work or just merge the code to be fully compatible and not need the hotel collector, but on this example on the demo you will find the hotel collector instead of GigaPipe. Okay, so if you guys are still confused, I can maybe answer your question at the end. But maybe you are up to some fun? Yes? Okay. Good. So let's discuss some fun on the mobile.
So I'm the fun part? Wow. Look how beautiful. Look how beautiful the picture is. So thank you very much, Rita, for this part and for all your hard work to make all this mess some kind of observable in our systems. So again, Voicenter, we're also an MVNO in Israel. We just launched the network and we're establishing all on OpenSIPS with many, many different parts. As you can see, its nice logo is over here, over here, over here, over here, over here. Many other deployments, but each one of those is a different flavored OpenSIPS that's doing what it needs to do in its task in the mobile network. We have the PCFCF, ICFCF, SCFCF, all part of the internal functions of the IMS. If I zoom out just for a second to see what we're looking at obviously the MNO part, where is the radio network, and let's just imagine a SIM card connecting to the radio. And all this part is part of the MNO radio network, and many of the internal communications that pass between the MNO and the MVNO are on diameter protocol. And part of the challenge that we gave GigaPipe folks and Rita leading the way was to give us observability just the same way we're used to use it and troubleshoot signaling in the amazing HEPIC solution, of course. So we started collecting all the diameter signaling, and later on we can see that we have actually a small lab over there. Can you show the little white antenna? So just so you understand what we're looking at, as this and the little two boxes are a complete mobile network. Yeah, we have the antenna. Well, it covers only about 15 feet, so if you go all the way to the window, you're probably not going to be our subscriber. But if you want to pay us a few cents and be a mobile member in our network of community OpenSIPS mobile network, then we can definitely do that. And what we'll later do is actually call numbers and see them live on the trace, which is the crazy demo that we're going to do. So just to finalize this, it's the part of the MNO, the part of the MVNO that has all the interconnections between that. We'll try and go through a little bit, and you can see that this beautiful DRA, diameter router agent, is basically taking all the traffic, the diameter traffic from the MNO and transfer it, proxy it to the right parts in the MNO network. But, yes? Sure.
So really, as part of deploying our IMS in the mobile network, we are finding ourselves doing more and more requirements of doing different diameter manipulation. So actually, in the end, when we came to, we take our nice lab that we are building for years already with the wonderful guys from OpenSIPS, leading by Razvan. And when we start to connect it into the real MNO as an NVNO, we really understood that there is the main part that missing for us is like this DRA. And the DRA was missing for us for 3 reasons. First of all, from MNO perspective, those guys don't want to connect to any point of your network. They would tell you all of your connection going through one place. Makes sense. Think about it like if I will have now 10 different HTTP services in my network, the operator will ask to have one Nginx to work with. Like you would not send your customer for the microservices. You will have some kind of a proxy. So the same way with diameter, especially when we are talking about cross connection between different network. The second reason that was crucial for us, it's really doing those, each vendor, each antenna, each situation have their own attributes, and you find yourself more and more needed to do changes over the attributes over the diameter. And it's, if anyone ever tried to do it, you need to recompile the diameter, and like it's really a pain on the ass, and we really were looking for a nice and easy way to do it. So we find ourselves, and the third reason, which is actually the more crucial and also connected to our partnership with GigaPipe and QXIP, is like to have like one point of observability of the system. So first of all, to be able to collect all of the app message for all of the diameters, send them as app, have them as part of the Epic, the commercial Omer solution that we are using, and from doing all of the billing and the metrics. So there is a specific interface that called GY that doing all of the billing, and you get the consumption of the customers that are using the network. And then, so it made us really understand that as a community, we are missing this part. And generally, we build like more of a POC right now for it, but it's actually going to with us to production. It's based on Node.js. We can later share, don't know, can later share the repository if we ever want to do that. But the future is really to build with QXIP some kind of probably a Go or even a C native diameter agent that can do the routing and the observability for it. So,
yes, thank you. So this is the link to the IMS stack in the community edition. Feel free to explore and play with it. And there you go. He was mentioning and discussing exactly that, the diameter routing agent. And in general, the most important features, as he said, the flexibility to route the diameter request to the right microservice behind the scene, and the ability to interwork with other parts by the ability to manipulate things. And of course, the HEP protocol support and session management that we will show in a sec. So in general, that's the basic configurations of the project, and I'm not like going to review the project and all its settings, but it's really important to say that it's that simple. You see the last few rows here about the host and the IP. That's basically how to set up the HEP to be sent with this project. And I can also show you on the Git itself that the function is actually taking the host and the port and is just building up the different values needed to be passed inside. Okay, so it's pretty simple for anyone that knows how to read Node.js. Again, you see here all the peers that you need to combine and connect. The DRA, as I said. Oh, sure, thanks. The internal connections involve, and it needs to be connected to the HSS or HLR. HSS is like the home station, home server, home subscriber server, and the HLR is the home location registrar. Basically, it's the kind of the same stuff. This is the only room that I can do this analogy and people will understand. It's kind of like the contacts table, okay, in OpenSIPS that, you know, the network memorize the IP and port, the location of the subscribers. So it's basically the database of the locations of the subscriber. And many of the send capability exchange, for example, many of the things that the network is checking, hey, is this subscriber allowed to subscribe to the network? Hey, is he allowed to make outbound calls? Is he allowed to get in calls? Is he allowed to get data connection and surf, and how much? What's the rate limit? So all these kinds of dialects inside the network goes through the diameter request, and obviously the HSS is one of the most important microservices in the network to provide this information with. And we have the PCF-CF and the ICF-CF, and again, there's more configurations there, like the route to the PCR-CF. Basically, they're all doing many different functions in this internal communication. The P stands for like a provider, like proxying all the things into the network. So usually we will see the signaling coming to the P and then passing either to the S or the I.
So just to be more clear about the struct of the different rules. Go back to this slide. So you know what, one even back to the peers. So generally the idea is that while we are setting up the diameter, we are given an array of entities. The different entities that have different roles inside of the 4-5G networks. And in the end, after declaring the peers, when the system going up, it's already making the connection to them, open the peers. So as diameter, we always want the connection to be open. So when someone reaching us to us, we don't need to start the dialogue. We always like leaving the connection opens and doing what called watchdog, which are the ping options, the alternative on the diameter stuff. And after defining the peers, we can define the rules, go on, which each rule say based on each condition. So we have an array of condition which packets are coming into these rules. So we can do it based on the any attribute and make a list of rules, like if this one contains this attribute, if this message type from this type, whatever we want to do. So you have a very flexible way of creating the rules and filtering and making the actions that you want to be done only on the specific packets. And then you have the list of actions that you can do. And if we will look on each action, so you can define like different applications, like, so a small application could be just send the log request about it, but a different application could be do this manipulation, change this IP to this IP, change the attributes. So any type of so a lot of the headache by building a IMS network is all of the interoperability. So different vendor asking for different attribute. The 3GPP protocol is very wild, but as any RFC and everything, some people, doing it things different, and then you find yourself to need to do some manipulation sometimes in front of different vendors, and this is a great way for us to do it.
So before we move to the OpenSIPS JS library, let's go and show some stuff. Where is that browser? Yep. All right, so first of all, let's start with the beautiful epic that we have here. I already created some queries ready for us to see. I can, query, for example, let's start by trying to make a phone call. Can you get this? And someone dials some random number, so it's not pre-made. So we have like the demo feeling. Type some kind of random numbers here and dial. Just to show, okay, I hope the reception is good with the antenna here. Hold it this way when you dial. Hold it this way when you dial. All right. Mobile network not available. Okay. Yeah. Anyway, 111-222-555-888 and the magic digit 9. Got it. Send. Mobile network not available. Okay. I swear I just did it before we started. So. Yeah, exactly. Try to get that to connect. We can actually troubleshoot and see registration and see other communications. So I will start with that. Until it just get off airplane mode and back to connect it. So I will show now, for example, registration flows. We'll just take this one and double click it. So now you can see that the actual phone, this is not SIP, this is diameter. And that's the beautiful part we see here. It's the communication between the phone itself, in this case, OnePlus. You see the signal incoming, the invite coming to the PCSCF, moving to the SCSCF, and then going to the registrar and coming back. And you see that all those packets are complete.
This is actually the IP. It is SIP in the IPsec of the IMS stuff. If we will go, can you go to the registration, take the IMSI and look for it in the registration flow. You will see also the diameter packet. So for us, one of the challenges that was as moving from a VoIP company to becoming an MVNO was really about making our guys understanding the flow of mobile network and combining the diameter request as part of the SIP flow inside of the epic, becoming like a crucial thing for us to teach our guys and show them how to troubleshoot mobile network. Because like a lot of time, like the problem is that you are trying to connect to a carrier that you don't have a roaming agreement with, or a lot of stuff that we have coming much before the SIP level issues. But for us, having the same troubleshooting tools of the troubleshoot SIP registration and troubleshooting mobile registration gave us a lot of control from that perspective. Oh.
Call flow?
No, the registration if you have, but if not, let's go on to...
Yeah, so this is how you see an invite message coming out of the device. Very familiar invite. You see all the SDP. And you can actually troubleshoot and continue the flow. In this case, unauthorized, or you can follow up and see the cause. All right. So, everyone here using Homer? Yeah? Good, good. Just to make sure. Just making sure, watching you. And let's go back one more. So we saw the invite flow, we saw a registration, we can show some, and we also have some other diameter flows. You can see coming from the cell phone or from the PCFCF. Let's take, I guess, this one should have some nice flows to show. So this is his invite. Let's see how that is finished. So you see the buy here. And you see media barrier loss for that case. So we can actually troubleshoot and see why the buy was lost, why the buy was sent by finding the reason. Again, any flow is now capable of being troubleshoot when you capture everything and you put it in a nice, friendly signaling display. Moving forward from the IMS, more stuff on the IMS, I forgot. No? Good, good. So in general, we all know the metrics collection, Prometheus collection of metrics. Anyone here not familiar with Prometheus? Okay, so just, it's a...
I think that like one of the things that people are a little bit confused about GigaPipe, a lot of stuff, it's like how do we push those data into the system? What are the tools that give us to collect those data? And for us, it's like one of the goal of the GigaPipe is really to have a unified interface based on the market already exist interfaces. So when we are talking about the observability world, we are talking about 4 main interfaces that any system that respects itself already supporting. The first one, of course, is the Prometheus for metrics. As Vlad was doing a great job last year and adding the Prometheus route as part of part of OpenSIPS, and actually adding, later we discussed the custom Prometheus route, so you have actually a dedicated route inside OpenSIPS that you can configure your own metrics and do your own analytics based on the profiles and the performance of your own system as it's running. But generally the idea is that we have the Prometheus, we have Loki for logs, we have open telemetry from all of its type, but generally is mostly being used for tracing. And we have the Pyroscope for profiling. Later maybe we can talk a little bit about the difference between tracing and profiling and show a little bit more demos of it.
Great, thanks. So as part of you all know, and as they mentioned, part of collecting the metrics in Prometheus is actually having an exporter, something that scraps, goes to each one of those microservices, pulls down the data, and then sends it to, in this case, of course, GigaPipe, which inserts it, in this case, again, to ClickHouse. And we found it to be a really nice holistic solution. I will show some Grafana porn now, so get ready. You can see this is an example of seeing how nice the OpenSIP load balance between the different media gateways. You see that none of them does not exist the whatever threshold of 100 calls simultaneously we decided to have emit. And you see the nice threshold that if it passes, we get alerts on. You can see the cumulative, amount of total calls. You can, of course, filter in the Grafana, to a specific host and not necessarily all of them, which is, very important. If you want to drill down now on only one of them, one of them has an issue. Now you can see the entire dashboard specifically on that host. That's a few examples on the asterisk. These are some nice examples of us collecting metrics on the RTP engine. For example, showing when it has some interface errors, or how many packet loss does it have to make sure it's always 0. Or the average, the title here is wrong, the average duration of the call. Okay, to see that there's no drops or skips or peaks in the statistics, and it's all averaging up the same way it should during the day. This is a nice, like a bit more complex situation that we want to check for the ratio in 5 minutes between the amount of 200s and 407s or other errors that we might have in front of specific providers. But at night, there's hardly any traffic, so there's hardly any errors. And in day, there's lots of wild stuff, people hanging up, phones going into tunnels and stuff. Like, usual life brings some errors, and then even the smallest threshold will trigger you false alarms. So one of the tricks we did was like to take, like let's say the total, you see in here, the total 200 divided by the total 200s plus the 408s, average in the last 5 minutes. So it's always giving you the ratio, and you see if the ratio of 200s versus the errors that you're searching for might give you a better. Yeah, go back. Yeah.
Nice, just to say that, as you guys can see, it's reading from Prometheus, not directly from ClickHouse, because it's using GigaPipe, which means that you are not making queries directly to the database. So you are taking advantage of GigaPipe, the chunking on the reading that benefits you in terms of performance. This is exactly like an example, just an example that you can monitor OpenSIPs using GigaPipe. You don't know. You don't need to carry about SQL queries directly to the ClickHouse endpoint at all. It's just all GigaPipe.
Yes. Good point, which takes a lot of headache. It's not like you want to be in a situation that in psychology there is this term that is called the observer effect, that if someone is participating in some a psychology test and he knows that he's participating in this survey, then he's behaving a little bit differently, which means like you behave a bit different when people are looking at you. And sometimes that happens to servers from different reasons, but sometimes, you know, trying to observe the server makes it overload and makes you see stuff that if you would not look at it, it would not happen. So I just find it amusing to call it the observer effect, just like in psychology. And this is a very good point that once you're working with GigaPipe, you're not ingesting into your own data centers, your own network databases. You're doing it clearly from an outside stand of view, and really I can go crazy and, you know, change this, let's say just 2 days back, okay? Haha. Okay, boom. Okay, I have the 2 days back amount of 200 replies, you know. It's not really taking more than a few seconds and query really fast and well performing. Let's show some more stuff. Let's see. Sure, of course. Can I trace what? Handlers. Handover. Yeah, you want to talk? Yeah.
So generally, you can monitor anything you want. So first of all, there is the set of metrics that OpenSIPS stats have. As all of us know, each module, as part of its documentation, you can see different statistics. So I'm not sure what. Some of the statistics that you might look already been in the dialogue or the TM module, but if not, and most of the time you find yourself doing like a specific picky data that you want to do, and that's the way we are doing it, is like marking it up and then by the dialogue profile and then counting it as part of the Prometheus route. So generally, later we can discuss it a little bit more, but you have your own route. You know what, let's discuss it a bit. Can you go into Prometheus module? Let's discuss it. So generally, anything that you can do with MI command or anything that you can do inside of a route, you can export as a metric. So the idea is really to be able to, so let's say you have even a specific use that you want to do a counter, then you can just use local memory or something to count those. So Like you can use any of the already exist mechanism that there is inside OpenSIPS and just expose it as part of the Prometheus route. This is go to 3.5, try 3.5. Stop living in the past. No, .x. Prometheus, look for Prometheus. Thank you. Yeah. Scroll down a bit. More to the script. So here is like the example. So part of the configuration of the Prometheus module, and you can see, you can define which route you are going to and what is the AVP which you are looking to see the JSON which will have the extra custom metrics that you will add. And then you can do inside of this route any logic that you want, like doing MI that count profile, doing anything, any of the logical actions that you want, and then you are building a specific array of headers and array of metrics with name and values. So you can define whatever you want inside of it, and then it will be part of the output of the Prometheus route. That makes sense?
Yeah, so you don't monitor it. It's something that you would have to add in by using.
Like again, like generic question, you know, like any specific activity that you want to monitor, unless it's already been monitored by by one of the existing module, you will need to add your own logic of counting it. But again, it could be even like use a local cache for counter, and then you just have the counter, and then you are doing metrics based on the delta. So there is many ways of doing it. It really depends on the use case.
We just saw in the example in the code the amount of enabled and disabled RTP proxies inside the cluster behind the OpenSIPS. Sorry. So I go by and we can see here the metric that we actually took two different metrics and calculated together the total RTP engines minus the disabled one, which will obviously give us the final result of how many active enabled ones we have. And if that drops or changes in some way, we can get the alert and go to the graphs and see what happened when, etc. Just quickly, a few more nice observability tools that you have on OpenSIP. Of course, all the activity in front of RabbitMQs, all the MI commands, the amount of errors it has, the amount of CDRs it reported, the amount of disconnections or failed MI commands, disconnected. Of course, the load balancing on the different instances that you can go and see if any one of the workers is now picked. And, of course, the amount of active dialogues. So if you have any end device that is, brute forcing your server or abusing it in some kind of way, you immediately see the spikes and can troubleshoot and see which one it is. The active RTPs which I show, again, the RabbitMQ metrics, the SQL requests, really important metric to monitor when using OpenSIPS with the SQL employment. Of course, all the amount of errors to see anomaly in the 400 errors or the 200 or the 500 errors. Of course, it can be in front of a specific SIP trunk or a group of trunks or generally in the cluster, so you can identify anomalies really quick and solve it before it actually escalates to issues. So I have lots of geeky stuff, but I guess that's it. You see like a really global picture. Oh, sure. This is an example of the amount of active dialogues that each subscriber has. This is really an important security feature because many of the behaviors of hackers are once they achieve the credentials for the SIP, they start registering in as many endpoints as they can to start doing abuse of traffic. And you can notice if any of the extension has more than the one single dialog of registration. Sometimes it goes to 2 with some other invite or subscribes, but that's about it, and it goes back to normal. It gives you a really good sense of security to know that there's no such thing as an end device registering more than the amounts that you allow him, or manage more dialogues than the average you allow, and that you will get a real-time alert on any of it. And now let's go to the traces. Yes, good. Let's take today. Yeah. Oh, sorry, missed that. So you can see different voice bots that are running in our system. I will just go to one of them. Let's take a minute 53, a nicer, longer conversation just from 8 minutes ago. I will go into the trace itself. And again, this is a voice bot call. No human was there to tell us what happened there. We want to see what happened there. And this is the nice trace of, all the different parts.
Yeah, like one of our challenges that we, when we start to deploy the voice bots, was really understanding what are the mistakes that the voice bot are doing, and how we should improve his behavior. And most of the time it's a prompt engineering, but if you don't have the visualability and you don't see exactly what happened with the different flow of the calls, you don't really understand why customers were complaining or why the voice is not acting ideally. And the ability of having those full visualization of the tracing of from getting all of the WebSocket event from OpenAI, Gemini, or any other of the providers, and seeing how the voice from the client is coming, and see what is said and what they said back, and how the dialogue was working around, was one of our key components for really launching this product. And again, I think that tracing as a tool is something that should be much more used by engineering and developers. Like if we are generally looking on the philosophy of trace, what is the difference between trace and log? So trace have 3 main differences. The most important thing, trace have hierarchy. So we have what's called span, like each activity could have sub-activities, which giving us really the ability to see what happened inside of the application. Under each activity, we have also list of events that could be like logs that have a specific timestamp. But beside having the hierarchy and having a list of events based on each activity have a timestamp of start and timestamp of stop. So this kind of data struct of the tracing is being given to people much better visualization of the application. Because usually if you write application, you know that this line created this line and you understand the flow and what happened behind the scenes. But if you are not the guys that build it, and if you are really looking to try to understand where is the bug and what caused what, really tracing is a great way of doing it. And there is, for me, it was always some kind of confusing between tracing and profiling. So tracing, it's more like an applicational, it's like more like log. It's being done by the developers for the end user to be able to understand the code. if we are comparing it into profiling, which is the pyroscope endpoint, if you can move to the last tab with the pyroscope, no? Yeah, no, one to the left, yes. Yeah, so if we are looking on pyroscope it's more for tracing for the developers. So when we are looking on pyroscope, like usually we will use, you can do it two ways, like as part of the 3.6 release was the plan of OpenSIPS guys to also to add the pyroscope tracer as part of as a module. But actually you also can just use eBPF to trace any of those activity by yourself. But when we are talking about profiling, profiling is a tool for a developer to know how to make his code better, to understand what resources, what each one of which steps took what. So let's say that profiler is a tool, a pyroscope and profiling is something that developers need to have to make their code run better. Tracing is something that end user need to have for them to be able to understand how code is running. So it's like a totally different thing from the use case, but they are very much the same from the concept. But each one of them should be used in a different way. You don't want to, you cannot give a QA engineer or a support guy to look on a pyroscope dump. You will not understand all of those kernel calls and why they really care about that. We care about how the application is running. So, yeah.
Yeah, we have the OpenSIPS JS.
What time is it?
It's already 4.
It's already 4. So let's go to the metrics of the OpenSIPS JS and go and finish from there.
Sure, but you want to show what it is first?
Yeah, all right. Let's start with the OpenSIPS JS. So, all right.
Next show.
Next show. So, I don't have a presentation, just code. No, just kidding. So, generally, as we discussed, we were going to talk a little bit more, talking about the OpenSIPS JS. So, the first, we will talk about, probably start talking more about like the testing framework. There is a lot of guys that was asking me a question about it, so we will start with that. Later on, we will probably, if we will have time, can play a little bit with a new repository that we added with a React native demo. So each one that want to have his own iPhone or Android application can compile it and run it from there. And yeah, and in the end, we can also discuss a little bit. I totally forgot about the future roadmap of OpenSIPS JS. So let's start first of all from the talking a little bit about the testing. So if we will look about like a basic example of a testing scenario, like that I just ran, will be running like what I'm doing now, I'm running like a scenario. Let's see where it is. We'll put volume. So what it's doing actually right now, we behind the scene, it's doing an HTTP request, filling out in both of those browsers call. Oh.
Good morning, thank you for calling Tech Support Solutions. My name is Sarah, how can I assist you today?
So what it's now they're doing, they're talking to each other. Shut up, be more quiet.
I'm sorry to hear about that connectivity issue. Let me help you troubleshoot this. Can you tell me what type of...
So generally what we did was like running a scenario file. Like while it's running in the background, we can a little bit look on it. Like you can see that like the scenario file is sample test simple. So if we will go on in the test, what it was, the core samples. sample test with sample. So if we will look in here, this scenario is like we have like two JSONs in here. One is the customer, the second one is the representative, right? Each one of them have its own actions. So we are seeing that when you are ready, we are running an HTTP login to our API, putting those parameters that are coming from the environment variables as inside of the scenario. And then based on the response of this API, it will push it into specific attributes that we defined in here, the caller login API response. And later, generally, we will be able to use those as part of the register command of the SIP. So the idea is really, we were trying to be inspired by Postman, by the idea of having the different action which you can use with figure as talking to each other, but we are also doing old, waiting for 3 seconds, and then doing unhold and waiting. Phone activities by itself, and of course the play sound one, which you can create any sound that you want, which also was one of our requirements to have a good testing tools for VoiceBot. So one of the things that you think about on VoiceBot, you really need something to call it, make a human sound, make a conversation based on what you see, what you expected to, and see the end result, that the call being transferred to the support because it was complaining on some support issue, or in the data that we got from the bot. So one of the things that we are doing in our bot is making sure that each bot have each intent, each time we are taking a customer into a specific IVR, we also can define which parameters do we want to collect from it. So let's say that you have a technical issue with your router, then we will want to see that the AI also know to recognize it and move it as part of your pop-up screen and all of those kinds of stuff. So really the idea is to have a good way of testing stuff. So OpenSIPS JS testing platform was becoming also our VoiceBot testing platform. What else I should say? First of all, anyone have any questions about it? I'm just pitching. No, no one? Really? I'm that boring? No. All right. Let's look a little bit about the log and the let me find with the chat. Where is Ostap?
Put it.
Where it is? So, first of all, like a minute ago, right? Like a few minutes ago. Nice. So we actually 1 hour ago, we succeeded doing it. We got like the documentation of all of the metrics that the test is like creating. So first of all, we can see like all of the WebRTC statistic that we are generating based on the RTCP that being exposed on the end of each call as a summarization for it. We don't really care about monitoring the test during the test. We just care about having the end result of each test. So if we will look about how does it look inside of the Grafana, let's look. So if I will look over the OpenSIPS, so I can see all of those parameters. If I look for the jitter one, let's look on the. So actually, earlier what I did, I was running the test. Let's scroll down a little bit on this one. Oh. So earlier I was trying to run like a different test while I was connected to the hotel Wi-Fi, and then I moved to my cell phone as a hotspot. And as you can see, like there is a change over the jitters that I was having, like not a big difference, but it's still, you can see like the jitter went up when I was on the hotspot. So again, like you can do many kind of monitoring for it beside using, as we are using it like if we are trying to really go over the different usage that we are doing. So first of all, it's really the stability of the data center, the connectivity stuff. We have put in those ones around different networks around the world to check each region of us and check the connectivity level and the stability of the hardware and everything like that inside of our data center from the outside. Really the end-to-end testing is the real way to know that everything is running. Beside that, of course, we are doing all of the functionality testing. So doing login to, as I show you, doing the login to the, as a user, getting the JWT from the login, getting by this JWT the setting of the browser, doing all of those kinds of end-to-end testing. So checking your API and checking the latency of your API, all of those kinds of stuff are being amazing for us. The voice bot, as I was saying as well, and also a lot of like, what else?
We went directly to monitoring, but you want to link up on the OpenSIPS JS?
Yeah, let's go a little bit on the OpenSIPS JS itself. So first of all, like we have the new website with all of the documentation in here. So if anyone was not sure where to find all of the data, we can see it in here. So this will be, so those are the different components as we discussed. You can find all of the documentation for each one of them. So if we are going a little bit, so what we wanted, probably let's talk a little bit about the Janus integration, right? So from the perspective of how does the OpenSIPS JS work with Janus? So first of all, let's talk a little bit. Oh, let's see the Janus module. So generally, just to understand like the way we are working with Janus. So the Janus module being that Vlad was developing is like acting as a proxy between the SIP messages themselves. There's usually will come from the WebSocket on scenario of web RTCs. And it's been sending those messages as a proxy into the Janus servers. You can work with few Janus servers. You have a table of Janus like that you can prefill as much as you want. The module by itself already know to do the different load balancing based on the room of the participant. So if we have multiple servers, each room, of course, must be in the same server. Each group of people that want to be able to broadcast each other must be pointed to the same Janus table. So generally, from the routing perspective, when the Janus message is coming, we can handle the Janus send request. And the way that, so until now, all what we were talking is about how the OpenSIPS JS send request, the Janus module take it, send it into Janus, Janus responding, we got back a response. But one of the things that we are having inside of a conference room, it's always, we have different events. So there is different kind of stuff that could, let's say someone leave the room or someone join the room. Those kinds of events must be somehow being sent into the endpoint themselves for the different dialogues that being opened and being a part of this room. So what actually we find ourselves doing is making a new event route that called Janus events, that based on this event we are looking, doing the logic. Usually we are looking based on the dialogue profile, looking which dialogues are being part of this room, and then sending the notification, a notify message to those people. Any questions? So, first of all, yeah, like the participant that you are getting, let's look at it a little bit, how does it look behind the scene. So, first of all, when you are connecting, you are getting a part of your join response. You will get the list of participants, of publishers, if you, where it was.
So usually, like you using
now it's empty because it's like an empty room, but yeah.
You're using like a SIP as a transfer.
Absolutely, absolutely, absolutely. So the SIP is like the transport layer in front of Janus. Like, so it's like, so in the end, if you are looking about Janus topology, Janus have already by default multiplied transport level. So you can use HTTP, you can use WebSocket, you can even use RabbitMQ, you can do multiple, you can manage the events and the message between the endpoint and the user by default by multiple transport layer. And what we did is just moving this transport. So we actually were using the WebSocket transport layer in front of Janus. And if we will, let's see if I still have it open here. You can see a little bit of tracing. Yeah, so if you can see, like, this is like, no. Let's see if I was having. Yeah, so as you can see, this is like an end grab between the OpenSIPS and the Janus, which you can actually see the all of the WebSocket between the port 80 of the Janus working in front of the OpenSIP IP, which is like a WebSocket client. So OpenSIPs becoming the WebSocket client in front of Janus. Actually, we are just opening one WebSocket. We don't need now opening a WebSocket per connection. We have in just one WebSocket, and based on the topology of Janus, we are now creating. So when you are connecting, want to connect a new connection from Janus topology, the first thing that you are doing is actually creating a session. So if we will look about like the invite. So the invite is actually doing a touch for Janus plugin video room. So when you are creating a session, you are creating, you are first attaching into a plugin. And the next thing that we are, and then we are getting the session ID, which is the handler ID. This is like our communication channel. This is the ID which identified the connection between this client and Janus. So this ID is being the one that Janus used to correlate whose message was coming from who. Because now all messages actually coming from the same WebSocket as one big, it's like there is only one user in the whole world. But no, actually OpenSIPS is just transferring it, and Janus by default working in this way. Even if you will take this kind of ID and move it between different browser, it will still work as long as you have the authentication level take care of. So Janus from that perspective is pretty much like, don't really care about from which transport layer you got into the activity. You can generate it from each one of them as long as you are following the same session ID, that the session and the handle ID that Janus created for you. And then as we can see, we are sending the join message. So we are seeing two types of subscribe message that we are using. One is for you when you want to start publishing the data, and the second one is for you when you want to receive it. Let's see how does notify look. So notify, you can get a different notification about different event. Like for in this case, we have like an event that tells us that this session start to receive a media. Or like you can get like different kind of events that going inside of your room, so you know exactly what are the state of the other participant as well. So if someone is leaving or someone is joining, you are getting all of those events. And you know how to re-render the HTML and to show the different display. So this is from this perspective. Any more question? Nothing? Yeah.
So basically, if you have only one function which is exposed by the Janus module, and you sending the request directly, means that I can, as a client, using my SIP credentials here, I can fake anybody, any type of body, and this body will be sent directly to Janus, right?
Yeah, yes and not. Like Janus shouldn't be exposed even to the real world. You just exposing like it's like you tell me like I am exposing my RTP engine port, my 22222 the control externally. Yeah, you could be hacked, but no. Janus by itself should not be handling any external connection beside the media connection.
Yes, I mean, you send the request to Janus using the SIP right now.
Yes.
Right? So if I will put my own body inside the SIP message, I will request Janus to, I don't know, show me all the rooms, join any of the rooms.
But yeah, this is exactly where you need to do the application, like to do the authentication, authorization, and check each message what you allowed or what you are not allowed. So you need, this is exactly, but this is like, you know, it's one of the basic usage of OpenSIPS is really or each proxy is really to make sure that is protecting any microservices in the other side just to be with permitted traffic. So by definition, OpenSIPS is supposed to do it. But the best way that we find how to do it is like we are actually using using the JWT. It's still login. How do I log out? Just refresh. Yeah. So part of our effort really moving everyone into JWT authentication, besides it's much more secure and have a dozen other different advantage over plain username and password authentication, is that you can have much more context and much more information inside of the JWT. So you can say, technically you can say like if he's a manager, not a manager, if which room is allowed to use which sub-organization. So you can do all of this hierarchy testing and all of those business logic based on the data that you are getting as part of the JWT. Otherwise, yeah, you need a source of managing inside of OpenSIPS all of the user information and what they're allowed to do or not allowed to do inside of the conferencing. But for us, we found it much more practical to really define all of those kind of information inside of the JWT and not needed to provision all of those information directly into the subscriber modules. What? Yes. Generally, what we did in our implementation was to use the invite, the target in the invite, as the so. Yeah, I mean, then you can't predict which will be the number of the rooms, so you can't put this in a JWT token, right? No, you can do whatever you want. So generally, you can just as part of the. Let's go to documentation. So you have the Janus ID, and this will be the connection. It's based on the from. Yeah, I think it's hard-coded on the from. I already don't remember. I think it's been based, yeah, it's from the client side being done, but actually so pretty much Janus don't really care about the SIP message itself. So it's pretty much defining based inside of the JSON of the join or all of the other things. But yeah, you need to do like some kind of authentication check based on the body of the message before sending it. What? How are you doing this? Generally, just getting the message. Oh. So, like, if you will test, you will see you have like the. So you have the request body, like you have the body payload, and from it you then just parse it as JSON, and you can do any manipulation on it. So think about like anything that are coming from Janus. Oh, where it was.
I'm asking, I thought maybe you can share with us how you managing this, how you protecting your Janus from.
So yeah, absolutely. No, I wouldn't. Again, this is something that like, especially security stuff, I would not expose on the public presentation. But generally, the best practice is to have some kind of dedicated route that get the body payload as one parameter, get the JWT of the client as the second parameter, and then based on those, making the decision, are you allowed or not allowed to do this operation. Like, what else? Let's discuss a little bit on the React Native stuff. Any more question on Janus or anything? Anyone? So let's discuss. Oh. So generally, if any one of you want to compile React native application, in the last few weeks we got the request from few community members to publish it. because like a lot of time the people doesn't really know, like they have their own React Native developer, they have their own mobile developer, but most of the time those are non-RTC people. And the aim was for us to really to give any Android or RTC developer a good starting point to build whatever application they want. I will not go now on all of the installation process of and everything, but generally in some quick word for those of you, and I guess most of you don't have too much experience on compiling Android applications. So I will have a 5-minute overview, but as you can see, there is OpenSIPS React Native demo in the Voicenter team the repository. Generally, we will need Node.js as the compiler of the base compiler of React Native. And we do need also JDK from version 17. Again, if you are using Windows, Linux, whatever you're using, just make sure that you have in the right Java network framework. For building, like again, you can use, like there is Android SDK for CLI that you can technically build the application from CLI. But again, it's much more easier. There is the intellingent tool of Android. So there is this React Native, this Android Studio that's been developed by Intelligent and been supported by Google. So I guess this is the best, most comfortable environment to develop Android with. Of course, we need to make sure we are having the React Native CLI being installed as part on our computer. So for those that doesn't know, it's npm install -g, meaning that we are installing something globally. After that, cloning the project, going inside, doing the npm install. Important thing for anyone that want to build Android, you need to have those environment variables, the Android home and the Java home being as part of your environment, and you need to have those Android tools as part of your path. So whatever, when each time that you want to use any of those Android binaries or tools, or running the emulator or whatever it will be, it needs to be part of your system path. So when we are using running the application, usually we can run it over the local emulator or using, and I much prefer using this one, is to connect the phone with USB. You do need to enable the developer mode over your phone and enable USB debug, and then you lovely can run and debug your application, even do breakpoint on your phone, and like it's much, for me, I much prefer doing that than using the emulator, but you can also use the Android emulator that running virtual Android on your device, which is slower. So generally, after you are getting that, you can just do npx run React Native run Android, and it will already build it and deploy it on your phone. If you want later to deploy it and like again doing deploy it on the store, you really need to do also getting certification from the Play Store and deploy the application with the certification. Of course, I don't want to get too details inside of the push notification, but in the end, there is no sense to have a mobile application without push notification. I'm sure you all know that, like, for the last decade already, mobile operators, operation system of mobiles like Android and iPhone, pretty obsessed about getting the battery safe from our applications as developers, and they are pretty much putting any application that is not on the front screen, and even if it's on the front screen, after a while into what called snooze mode. What it means that you cannot have access to the CPU, memory, anything. It's like you are dying, and the only way of waking you up, it's with a push notification. So push notification, it's like a mandatory thing for if you developing any React native application, any native application. What else? So generally, we recommended using Firebase. We're using Google Firebase, which is the most common and easiest way to connect. They also support Apple devices, so you don't need to start connecting to different vendors for each type of new operation system. You have like one place that do it for all. Also, what we find very interesting is that Firebase working great with Chrome, Chrome extension, which giving us the ability to wake up the phone if they are stuck or stuff like that. So we are not using, when we are working in front of our Chrome extension with the OpenSIPS JS, we are just we are just using the push notification, not for invite, but just if you got a registration expiration, which means usually it's because your browser stuck, anything like that, like browser, they have like too many people that run in stupid HTML applications that eat the browser and kill it. And as someone in any browser application, you should be always be able to monitor yourself and make sure that you are still alive. There is like, so using those push notifications was a great way for us doing it. What else? Let's finish with the cannabis phone. Yeah. So. I was asking here Roy to make like a small demo from the OpenSIPS JS one. So let's first see how it's looking from the preview perspective. So we have like a lovely phone. We will. Whoop. So this will be our beautiful cannabis phone. And if we are making phone with him, you can see, like, you can see this. You can see the smoke over here of the cannabis smoke going up. So very nice, very nice. So like,
the widget and adapted it to it, and
like really. Like, look how it's flying nicely. So let's look at the code behind. No, wait. All right. Join the picture, exactly. Oh, sorry for that. So yeah, generally, like this is like an example of a very simple phone application. The idea is really for each one to be able to do whatever you want. As we see, it's like a very nice cannabis HTML. And beside that, we have like the logic of the phone sitting in here. So as you can see, it's like 300-400 of ugly line of code. Probably been done by an AI, right? Shame. No, just kidding. And, So you can see really how does doing all of the so generally you are sitting on based on the event of the OpenSIPS JS, building anything you want, changing the style. So generally any of web activity, anything that your web developers would like to do based on those RTEC events are being exposed as part of the OpenSIPS JS library. Yeah, I think that's enough, right? That was enough for today. No, just any more questions? Yeah.
Do you have I've just been trying the app, the widget on the website.
The what?
The widget, OpenSIPS widget. Does it have a CDN?
Yeah, absolutely. Yeah, I think there is supposed to be like there. If not, we will make sure for it. But where it is? So this file is supposed to work, right? Yeah. No.
Using DS at the end.
What? JS. Oops. Yeah. So yeah, it's up there. So yeah, you can use it directly from As we can see in the documentation, you can use it as your own NPM, as part of the NPM installation, or just using it plain old script include any way you want. Again, if we will look a little bit again about the basic configuration for it. So over here we can have the default SIP configuration. All of this is like the push notification. So generally, what we need to do to make the push notification work is on the moment that we are initiating the application, if it's Android, iPhone, or Chrome, we need to initiate the Firebase SDK or whatever SDK we're using from the push, and getting from it what called a PRID. PRID is this mechanism, it's this token that being in here that will enabling us as a provider sending the push notification to your phone. So like it's like the secret of this application, how to send the push notification. And as you know, this has been all of those PN parameters being pushed as part of the contact attribute inside of the SIP registration. And then, like, of course, it depends on which SDK you are using to receive those events. But then when you are using those events, usually you want to do re-registry, like based on the RFC that say that if you're especially working with mobile, you should, when OpenSIPS getting an invite, is holding the invite until the application doing a re-register, and only then sending the invite to it. So the idea is really to, and the ability of OpenSIPS knowing what is your token, what is your PRID, and how to send you this push notification is all based on this PN PRID parameters inside of the contact header. So, any more question? Anything you'd like to ask? Good, good. So, thank you again. It was a great conference. Bogdan, anything last words? Last words. So, thank you so much, Bogdan, for the great conference.
Thank you, Shlomi. So, yes, this workshop was more or less the last one for the day, and marking the ending of, let's say, the main conferencing part. We still have tomorrow for the ones registered on the training. So tomorrow it's only the training. And the training will be exactly in the same room here and in the same kind of a setup with coffee, lunch, and everything. Razvan, pay attention. We have lunch tomorrow, right? So, yeah. So, again, for the ones with the training, see you tomorrow over here. I think it's 9 o'clock. Razvan, can you double check, please? It's 9 or 10? Yeah.
10.
It's 9. Okay, let's make it 9 then. Okay, so training 9 o'clock tomorrow. For those not doing the training, thank you for joining us for 3 wonderful days. I hope you learned a lot of useful things. I don't want to ask, okay, like how many answers or, how many questions you had before and how many answers you got at the end. Or maybe the set of questions increased during the conference. But if that's the case, you can reach, the more or less the entire community via the mailing list, by the Slack channel. So we have different ways we may assist, help when it comes to different kind of development or usage things of the project. So yeah, that's answering to the question. It's a never-ending process, right? Otherwise, have a safe trip back home. And yes, hopefully we will see you. No, thanks. We will see you next year. Okay? Thank you for being with us.